and it runs Mondays and Thursdays, 2 times a week. Right now, it doesn't work for papercall, but it works for all of these other sources. And if you want me to add more sources, just open an issue, or you can also do that yourself by just looking at this documentation of adding a crawler. So you just have to import a base class and write a crawler for the website that you want to scrape and create a list, and it's that easy. And I just added PyJamisConf to a source that I'm tracking, and it got merged. So you can also set reminders for a reminder for PyJamisConf, which is going to happen in December this year. And that's mostly it. Thank you.
So last lightning talk of this afternoon, and then Daniel, you're ready to go.
Can't.
Daniel?
Can you hear me? Hi, yeah.
Yeah, I can hear you. And
you see me?
Yes. So if you are going to share your screen, please do that.
Yes.
Cool. So you have 5 minutes. Go.
Hi. I I work in a company where we have many people who are Java programmers, and when people are making the transition to Python, they might hit on the Python tutorial, which is kind of at the top of the search results on Google for learning Python. And this is kind of a standard tutorial. Many of you have done this, I imagine. I thought it would be a fun project to take the code examples that are given. So this is kind of written in a very kind of prosy style, and make it into an interactive tutorial. So interactive tutorials do exist for Python, but as far as I know, there aren't any open source ones. So I wrote one, and this runs entirely in your browser. It's relatively important for us, for my firm, to not be sending data out to the cloud. So this is implemented in Brython, which is an implementation of Python that runs in JavaScript, and it runs in your browser. In fact, so this is it. The interface for this tutorial is also written in Brython. So it takes a little while to compile the standard library, but it should have done this before. Dead air while it does something. Hey, okay. So this is the tutorial that I created. You can run any code example and it runs immediately. And there's two modes. There's this REPL mode and a different mode. It's not on this page, but you are invited to change the input and make the boxes go green. So that's REPL mode. Let's find another example. Shouldn't take as long to jump. So Brython is a little slower than Python for some of the operations, like regular expressions. But according to Brython statistics, it's slightly faster than CPython in general use. Of course, it's got that delay where it has to compile the standard library. So that's the other mode. So everything works in here, prints work, and so on. And that's all by shipping code off to a web worker. So there's two Brython processes, one running the UI and one that's executing your code. So you could print in a loop, for example. And those things would appear one by one. So the code for that is on GitHub. Something that is kind of unique to this is, I've got something in front of my screen. The lessons for this are written in Markdown. So if I was to see the raw code for this, it's all Markdown, and that's one of the reasons that it's quite slow to load those pages is because it's converting this Markdown to HTML and converting these code sections into the exercises that you see. So the editing experience for this is really easy, especially in something like Visual Studio Code. And this is how the exercises are defined. So exercises are just defined as test cases, and they just have some properties of the code section that's immediately above them. So that would be in the box at the start, and then these exercises, you just have to make them pass. The docstring, of course, is the text that is given to the user, and again, that's in Markdown. So that's my project. That's on GitHub at lordmove/Python now. I'm not going to be sprinting on it during the sprints, but I would welcome any PRs if people want to contribute, particularly on the content. Thanks very much.
Oh, thank you very much. Yes, thank you. Okay, so that was the last lead talk, because everyone is we wanted to test the karaoke talks. We have 5 minutes, so check. I have a proposal for you. Share your screen, and I will select a slide for you, and you can do the karaoke, or I can do the karaoke. You decide.
Right. So I just randomly click on the slides on Speaker Deck. So
Okay.
you can take that challenge if you want.
Okay, I can do that.
Yeah.
So what I want to do here is I want to promote, let's say this is a lightning talk about karaoke talks. And we want to promote, because tomorrow night our plan is to spend hours and hours and hours doing it.
Yeah. So
let's see.
Okay.
So the idea is that Chuck is selecting a random slide from the internet about anything, and I will have to present a lightning talk using those slides.
Right. Okay. Let's see if that works. And let me share my screen of that thing.
Okay.
And are you ready? Like, do we have a timer or something?
We have a timer.
Okay.
It's in EuroPython Society.
Can you time yourself, or do you want me to time you?
No, I have a timer. I'm seeing it. Okay. It's in the EuroPython Society camera, but it's already running, and I don't have a slide.
Okay.
So.
Okay, I'm sharing now. Okay.
Okay.
Can you see it?
No.
No. Where is the window is gone? Okay. Can you see it now?
Oh yes.
Okay.
Okay. Okay. Hello, everyone.
Hello.
Oh no, we lost
him. We lost him.
We just lost Nicholas.
Oh no.
JavaScript robot ate him.
Okay, like if someone can just share a screen, I could do that, you know. Or like I can do this one, but I think it would be more interesting if someone drive and I have to force to go with the slides. Okay,
oh, if you want me to, I can.
Yeah, please.
I'm back.
Oh, you're back. Okay, fine. Right. Okay, let me share again then.
Like really hard.
Yeah.
This is I say JavaScript and it crashed like.
Yeah, so it doesn't like JavaScript for some reason. Yeah.
Yeah, this is my talk about intergalactic JavaScript robot from outer space. And next slide, yes. Okay. In October of 2011, we open sourced the chatbot. The chatbot, it's a bot that is going to write JavaScript for you, right? So you don't need to work anymore. You just write what you want to do, and the bot is going to do that for you. This is our backend. As you can see, it's really complex. We have some chemical things working, and Hubot is there. We don't allow him to go outside, but we have some windows so he can get some lights and that kind of things. Yeah, okay. You know, time to time you have a bug and things explode, and then yeah, that day we were working like for a week to find all the pieces and reconstruct it. Yeah, and then in November, in the future, we are planning to release, and we are going to take over. So this picture is what's going to happen is JavaScript take take over the backend. So please remember it. In 2022, it's going to be a problem. So we need to do something before. Yeah, is anything that you can do to stop it? Yeah, you can join the Python community and stop using JavaScript. So tomorrow in our keynote, we need to combine Guido to run Python in the browser, and then we can save the world. Okay, and take care with that person, you know, like Terminator, when you go to the past, we need to find that person because that person is building this thing. And I lost my time, so.
You're running out of time. You still have three minutes. Come on.
2 minutes.
Yeah.
Okay, so other thing that's going to happen if we don't stop these JavaScript intergalactic robots is that this bridge is going to explode, and that's going to be the beginning, right? After is the whole planet. The best that we can do is what this picture is showing, right? So we can take the JavaScript bots and we can send them to the garbage, or we can teach them Python probably. I don't know, that could be a good idea. Yeah, this is a really good example that I'm using to show you how the things work. So it doesn't make sense. So you have some random table, random numbers, no one understands. I believe this is a date in JavaScript, probably. Yeah, so to be honest, I'm like ranting to JavaScript, but JavaScript is nice because we have the web, right? So we have really nice things. So we went back and we started from scratch, and we learned that there is a good way to use it, and probably we are going to make a piece with these intergalactic robots, and we are going to work all together in backend and frontend and different things. Yes, that's going to be a lot of fun.
You're not done with the bot yet. You're not done with the bot yet. No,
yeah, so
we still have a lot of slides. You can still carry on.
This is my last slide. And so as you can see, we have a really nice design. GitHub is helping us. And there is a lot of people working to make JavaScript great again. Yeah, so thank you very much for joining me. Be careful because the intergalactic JavaScript robots are there and we need to solve them. Thank you.
Okay, I'll let you go.
Okay.
Right. Maybe we should shorten it to 3 minutes, otherwise like people really struggle.
Thank you. So
right.
This was only a way to show what we want to do, and yeah, I know it's okay for me to be embarrassed in front of everyone. So if any person wants to do this. Okay, so in a few minutes we are going to have Nomi Seder. It's our afternoon keynote. Hello, Nomi. Thank you for joining us. And I'm going to leave now because I'm creating too much chaos, I think. Thank you.
Oh boy, I'm not sure how I'm going to follow up on that, guys. That is fantastic. But thankfully, I don't have to follow up because I'm not the person who's going to be speaking for the next half hour.
Right. So, are we ready to have our keynote, or?
Yeah, I think we are just going to make sure everything is ship shape for that. So oh yeah, and there she is. I think she's all ready to go. So I'm gonna wait I am gonna wait a minute more though, because we've announced this for the top of the hour, and we don't want people to come in and go, oh no, I'm late, and miss the first part of this brilliant talk. So absolutely. So if anybody is sitting here going, okay, well, what do I do now? Well, if you don't want to hear me blathering for the next 60 seconds or so, go get a refill of go refill your coffee from your percolator, get a fresh pad of paper and a pencil, and at the it looks like about 2 minutes, probably less than 2 minutes, we'll kick off. think I need to unspotlight Chook because she's spotlighted here. Oh no, you're not spotlighted. Why is it locked onto you? Oh, it's not
Because
locked
people
onto
want
you.
to look at my face, and I'm. I should just like leave my chair, and so you can stare at an empty chair. You can stare at my like massage pillow for my neck, and
Yeah. There you go. Yeah, a little plug for that brand there. Okay. So yeah, this is that period of time where I wish I had thought to get the little slide up on the VM, but by the time I would actually get that up to say we'll be right back, it would be time. So I'm just going to try and fill in the space with who knows what. This is harder than the slide karaoke actually, because I don't have any slides to karaoke off of. That's all right. So actually, we're about at the right time slot here. So everyone who is wandering in or who has already been here for that the awesome lightning talks, welcome back. So we are going to be hearing from one of our keynote speakers, Naomi Cedar. She is the outgoing chair of the Python Software Foundation Board of Directors. She's the author of the Quick Python book, 3rd edition, and has taught Python to diverse audiences for many years. She helped organize PyCon North America and PyCon UK, originating the poster sessions, Education Summit, Intro to Sprinting Workshop, and last PyCon Charlas. Wow. Very, very accomplished, very busy. She's also the open source development manager for Dick Blick Art Supplies, which I love that because I actually get all of my Sculpey clay from Dick Blick. So that is great. So everyone, please welcome Naomi Cedar.
Okay, well, it's a special delight for me to be talking to you today. My first EuroPython was back in 2014, where, as I recall, I committed the cardinal sin of running over a little bit into lunchtime, and I remember Alexander waving at me frantically, trying to stop me, but to no avail. And I promise you that I will not run over into the dinner time, which actually for me here in Chicago will be lunchtime this time. So I've been a fan of EuroPython since my first one. I've been a member of the EuroPython Society since 2015. And today, as I sort of look in the discourse channel and see lots of familiar names, I guess I'm filled with feelings of, well, in Portuguese they say saudades, this sort of feeling that you're missing people and good times. And I'm delighted to be here, but I really do, as most of us wish could be in person. But yeah, to continue here, I have to admit, I'm going to do some things that probably will give the presenters nightmares. So what I'm going to do is actually, I'm not going to use any slides. There are slides, and they do reflect what I'll be saying, but you don't. I'm not going to be showing them to you. Instead, I'm going to abuse the background feature. Let's see how this works. I can blame all of this on EuroPython because it was at that 2014 EuroPython, the first one I was at, that Peter Hinchins gave a really great keynote without using slides. And that's kind of been behind my temptation over the past few years to not use slides. I also, it is true, have been known to say that bullet point slides will suck the intelligence right out through your eyeballs. Please don't take offense if you're using bullet point slides. I just say things, okay? So yeah, that's sort of what's going on. As mentioned, I up until a few weeks ago, was the chair of the board of directors of the Python Software Foundation. I stepped aside this year, and that had been something that honestly I had been planning for a couple of years, that I was going to do that. I felt that 5 years as vice chair and then chair of the board was plenty. I wanted to give other people a chance, and I'd hoped that maybe this would be an opportunity to increase the diversity on the board. I certainly admire all the people that were elected, but I think, like a lot of people, the diversity part I was hoping for hasn't quite happened yet. I know that the PSF will be working to improve that. And I hope everybody will join me in supporting the board and the staff as they work through things that we might do in order to make sure that we have a truly global board to go with a truly global community. So as I say, my stepping aside was part of my plan. I had a lot of other plans, though. I had plans to go to PyCon US as I was, back in January thinking about how the year would shape up. We're going to go to PyCon US. I was going to watch some of those things that, they kindly read the list for me, so I guess I don't have to, of things that I'd kind of worked on to get started at PyCon. And I was going to enjoy that. I had even done a painting that I was going to donate to the PyLadies auction. You can see it behind me. I painted 45 different PyLadies logos as something that I was going to give away. And, I had various other plans for the year beyond that. When EuroPython was going to be in Dublin, that was pretty tempting. It's easy to get to Dublin from Chicago. There was PyCon Latam in Puerto Vallarta. I had actually bought a ticket to go to Spain for PyCon España again. And so I had all of those things kind of lined up. And then, to me, as to everybody else in the world, 2020 happened. And COVID-19 and all of the things that went with that. And particularly being on the board, there was the agonizing process of canceling PyCon. This was something that developed in January. It didn't seem like there was really going to be a problem. It was just this thing that was far away. In February, it started to seem like it was going to be a problem, but I was hoping maybe we could have at least a small PyCon before it hit the US and was a serious issue. By about the beginning of March, I was starting to do the math. If we've got a population of so many people, we've got a conference of 3,500 people, and we have this infection rate, what are the odds we're going to have people with the virus at that? And that was when I realized that it was pretty certain we weren't going to have a PyCon US at that point. A bunch of us on the board of directors, we were in the PSF board Slack channel pretty much 12 hours a day, every day, trying to figure out what was going on, following the news, comparing notes, tracking things. And I know a lot of people at the time, we saw the tweets, we heard the comments. A lot of people at the time were asking, well, why doesn't the PSF just cancel PyCon now? As has come out, and you will hear other people talking about this as well, the reason we couldn't do that is because with the contracts we had for the venue and for food and for hotels, we would have lost, the PSF would have lost and more than $500,000 if we would have just unilaterally pulled out when we saw things starting to get bad. We had to wait for the local governments to actually shut us down officially so that we could get out of those contracts. And that wasn't happening. I know I, for one, was watching the Pittsburgh area. They've got cases. Why aren't they canceling? Can't they see? And eventually that did happen. And then we went to all of our suppliers and we managed to get out of most of those contracts without much of a loss. And of course, people were very generous in not claiming their registration. Many of our sponsors were very generous in not claiming a refund for their sponsorship. So, you know, that enabled us to do all of the things that we could do. So it was probably one of the longer months of my life, to tell you the truth, as we kind of came to this conclusion that that's what was happening. And of course, it didn't really end with that. After that happened, the outbreaks continued to get worse. Places all around the world went into lockdown. I know here in Chicago, we went into lockdown officially and in late March. Knowing what was coming, I kind of did unofficially about a week earlier. But, you know, all of that happened. Travel was shut down everywhere. And then, you know, just as things were starting to look like we were improving, a cop in Minneapolis murdered George Floyd, and that set off a wave of protests, both in the United States and around the world. And you know, Lord knows those protests were justified. It's long overdue to address systemic racism, but it was a case where there was yet more turmoil, and it just sort of didn't seem to want to stop for a while. I think, you know, now we're in a better place. After all, we're at least an online version of EuroPython, and that, I think, basically made me start thinking back to some of the other EuroPythons, and you know, I think back to Bilbao, because I think Bilbao was one of my favorite spots for EuroPython. I loved the water and the Guggenheim, and there was the park. It was a nice venue, and I liked the city. Just in general, you know, a lot of really good memories about my time that I spent on both 2015 and 2016 there. I also then have to remember that I gave a keynote at EuroPython in Bilbao in 2016. It was, as I often do, it was about community. As I often do, I quoted Brett Cannon, his line about, I don't know about the rest of you. I came for the language, but I stayed for the community. As you might be able to see on the slide that's behind me a little bit, I talked then, I was worried a little bit about Python community. I was worried that there were forces of division, that there were forces that were going to make communities have a harder time to stick together. We had just had the Brexit vote. Right-wing populism was starting to gain a foothold, it seemed, in many places in the US, in Europe, and in other places as well. And so I was a little bit worried about community. And as I think of myself back in 2016 from the vantage point of 2020, all I can do is just sort of shake my head and say, Naomi, Naomi, you sweet, innocent summer child, you don't know the half of what is coming. Because, you know, indeed, if things were maybe a little bit concerning now, I would say that we're in a situation that really puts the notion of community under siege. And I think there are a lot of forces that are very seriously going to make building community more of a challenge. Or to put it this way, I think I'm not alone in saying I would go back to the summer of 2016 in a heartbeat if I had that choice. We've got a lot of things that we need to worry about. In some places, the virus situation seems to be under control, but we still have no idea whether or not there's going to be a second or third wave, particularly as the weather changes, winter comes in the Northern Hemisphere and things like that. And while some places have done a pretty good job of managing things, I think certainly on a national level, the US has given a master's class in what not to do to manage a pandemic. And sadly, we're not alone. We have company in doing things almost exactly the wrong way. All of which means that, on sort of a global scale, the pandemic doesn't really seem to be that much more under control, certainly not as much as we would think it should be. And I think going along with this, we will continue to have fatalities. And I think the thing I dread most about that, I haven't heard of any really in the Python community yet. There must have been some. I haven't heard of many deaths of people active in the Python community, but I really dread if the situation continues to worsen, if we don't get this under control, that we might start losing people from our Python community. I really don't want that to happen. And, sadly, that's only part of it, because of course we also have the economic fallout coming from this. And I think that we are just starting to really see the long-term consequences of this. Being Python programmers, Python developers, we've been sort of spoiled over probably the last 10 years, at least, in that our skills have been increasingly in demand. We can find employment. It's pretty easy to find a job, trade up to a better job. I mean, if you have any experience at all, this starts to be, relatively speaking, has been a good job market. And I think we're going to see that change. We're going to see that change because companies are cutting back on their budgets in a lot of ways. I think startups, particularly if they're not taking in revenue yet, are going to be in a hard place to find funding. All of this will mean that there will be probably fewer people hired. There will be more demand. It will become a buyer's market rather than a seller's market as far as our employment skills are concerned. And I think going along with that, we're going to see sponsors for community events, support for things that we do in the community, also be kind of pulled back some. I think with the fact that all conferences in person have pretty much been shut down now for a few months, I think there are a certain number of big sponsors who are even starting to rethink the notion of whether or not they will be spending as much money to sponsor in-person events when they do return. So, that's all, sad to say, pretty sobering. I think in a more general way, we're also facing a continued growth of polarization and conflict. And while protests and the drive for improved justice, to get rid of systemic racism and all of the other things, it's way past time that this should be done. But I am afraid that we will have repressive governments, regimes that will try to use that sort of protest as an excuse for repression, to remove the rights of all sorts of minorities, racial, religious, LGBTQ. I think we're seeing that in places already where there is an attempt to pull back rights and restrict rights. And some of this will be done in the name of the current crisis. And I think that will be a huge challenge for us as a community going forward. That said, I have before confessed to being quite old. It's true, I've been around longer than many of you, and I have seen some various things that are have been kind of challenging. I do recall the 60s and the 70s when, again, we had lots of protests, we had some economic issues, things like that. But I think I would also say that I have not seen something on the level that we are seeing now and that we will be seeing. In fact, the closest thing I can think of more is the 1930s and 1940s when we had a depression and World War II following upon that. And that was the era when my parents came of age. And I know that that period shaped them in ways that I really couldn't understand coming several years later. I think that the impact of what we are seeing today will similarly last a generation. So what are we looking at as we move forward? Well, you know, it's not that I really know, but having watched things, there are certainly some possibilities. We will be moving, as they say, into the new normal. One thing I can say is that I don't think the new normal is going to be much like the old normal, at least not for quite a while. I think we will continue to see greatly reduced travel. As all of the airlines and everything is cut back, has ground down to just a tiny fraction of what it was, I do not think that those things will come back right away. I don't think that there will be the market for those things to come back right away. So I would expect that travel will be less frequent, more trouble, and more expensive, certainly in the next couple of years. And, you know, who knows, as we start to consider the environmental cost, the climate change costs of travel, I'm not sure that it will ever come back. I think conferences, when they do come back in person, are going to be smaller. They're probably going to be mixed events where a large part of it is online. I think this will be a very different thing than what we have had in the past. As I say, in general, I think we will have fewer resources for community events, for starting companies. I think everything is going to be a bit more expensive. I just have a hard time seeing how we're not going to, over the next few years, have those sorts of impacts, along with, as I mentioned before, a tougher job market as well. So that's all pretty gloomy. I admit it. You may be wondering, so is there anything good going on? I just sort of saw earlier in the lightning talks, we have more translation of the documentation into Portuguese. That's good. Into Spanish, that's good. But I think there is, in fact, some other good news as well. I think the good news basically is that we're adapting and that we can adapt. And I think there are a lot of things going on with this. For one thing, meetups have moved online and seem to be flourishing. The picture behind me is from PyLadies Guatemala, and I seem to be invited to at least a couple of meetups a month these days. They seem to be popping up all over, or ones that were there before don't, seem to be having maybe even more events. And I think this is actually kind of an interesting and encouraging thing to watch, because when everybody's meetup is online, the organizers are free to get speakers from wherever. They're not just limited to the people around them. And on the flip side, when everybody's online, if you get asked to speak someplace, it doesn't matter whether it's in Guatemala or Amsterdam or next door, you can go ahead and speak at that. So I've seen a lot of international exchange, a lot of communities getting to know each other. I know there are even a few meetups that I've seen where two similar groups in completely different cities, completely different continents will have a meetup together. And I find all of that really, really cool. I love to see that going on. I think that we're adapting also when it comes to conferences. I think that conferences are experimenting. I think that this conference, EuroPython, is the grandest experiment in making a conference go online that I've seen so far. EuroPython always had many parts and was well organized and all of that, but the event, the effort and the experimentation to put on this conference has been, to my mind, truly stunning. I mean, for one thing, I mean, I checked their speaker's guide. The speaker's guide is 38 pages long. They have thought of everything. They've tried everything to try to get as much of a conference experience in online formats. I mean, we're using two formats. We're using Zoom and we're using Discourse, all of these things. So I think that as we continue to experiment with these things, we're going to see all sorts of interesting things happening with conferences, and I'm proud that EuroPython has been such a leader in thinking these things through and experimenting with all of that. We're also doing a lot to share knowledge. Here, this is a shout out to Chuck. I stole a screenshot of Chuck's Twitch channel because she's got so much stuff, but everyone is doing it. There are all sorts of free training courses springing up online, training videos. People are doing Twitch streams. We have Twitch talking about Python. We have Twitch streams where people are demonstrating Python. And I did several episodes myself of one I called Exploring Python that I may come back to when I get time. There have been all sorts of groups that have been putting on online workshops. So there has really been, as far as I can tell, an explosion of people sharing content, of people trying to get the word out and help each other through their knowledge, which is, again, it's stunning when you think about the number of things that you can find that people are doing these days. We're also contributing and trying to make the situation better through what we all do best, which is code. And that may be people contributing data analysis. It may be people actually setting up sites to share the data. I know there are several cases where the actual data involved in, say, the virus situation would not be getting out if it were not for the efforts of people in the Python community, in fact. And we're also even finding ways that we can use our skills to help support other people. The image behind me is from EuroPython, which was created by a member of the Python community in Paraguay. And it's meant to be an easy place for people who need help to put up a request, and for people who want to help to find people near them that they can help. And these requests are all very basic things. They need diapers, they need food, they want books for their shut-in elderly mother who can't get out because of the quarantine, or various things like that. And this was all sort of just done by, as I say, a member of the Python community who wanted to help out. So there are so many of the things like that. And, you know, as it's also the case that while the employment market is getting tighter, the fact that work has moved online, I think, is holds some potential for a lot of people. It's probably no surprise, but it did take a pandemic for business in general to realize that most of us in our business can do our jobs from almost anywhere. But this willingness to distribute and accept remote workers makes life easier for a lot of people. I think increasingly we will not have to move to an expensive hotspot city in order to get a tech job, but instead we'll be able to work from where we have family or just where we want to be or whatever it might be. So that, I think, is an interesting and a positive thing that is coming out of all of this. I guess that kind of brings me to the last part of what I want to say, and that is, what does that mean? Where are we now? What can we do as our global community of Python programmers? And I have at least my suggestions. I'm sure that there are many more. But one thing that I think we are doing and that we can do more is we can start to really use the technology that we've got. It's sort of interesting. We've had video conferencing now for years. And until this came along and we really didn't have much choice, we didn't come anywhere near using it effectively. I think as we're pushed now, we can really explore these tools. We can really test them. We can drive their improvement. And I think as a community, we're kind of positioned to be at the front of that in making these tools really useful for everyone in a lot of ways and developing them in ways that they haven't been. We can also continue to take care of each other. I think this is really important. I think we can continue to draw upon our communities to fight isolation, to be there for each other. I know this has happened to me a lot over the course of the past few months. People will reach out or I'll reach out. Hey, how you doing? I haven't heard from you a while. Are you okay? And I think that helps everybody when you do that. Certainly makes your day better to have somebody check in and say, hey, are you okay? Yes, great. Oh, well, I'm fine too. So I think we need to make an effort to do that. We need to make an effort to nurture all of those friendships that we've made in the various times that we've been able to go to conferences. And we need to make an effort to use these new tools to continue to find and develop friendships there. Maybe someday we will be able to meet them in person at a conference if things get back to that point. So we need to do that. I think we also need to be optimistic. And what I'm thinking of here in particular, Chomsky wrote something to the effect that optimism is a strategy for making a better future. Because unless you believe that the future can be better, you are unlikely to step up and take responsibility for making it so. So I think we've all had our days in the past few months, maybe of doom scrolling and being unable to shake it off. I think as much as we can, we need to try to choose to do things that reflect optimism. I think I've found over the years that sometimes doing things as if you were optimistic can actually help you be a bit more optimistic. But I think we need to keep in mind that as tough as things have been and may continue to be for a while, that we can be optimistic and we can expect things to get better and we can act in ways that will make things better. I think it's important for us to keep that in mind. In particular, I think we can continue to work on building community, on making our communities more inclusive, making our communities more just. We can continue to push for that. We can continue to organize, volunteer, and contribute to the community. Some people may say, this is a crisis. We can't worry about building inclusive communities now. I think that's exactly wrong. I think that because this is a crisis, one of the important ways we will get out of it is through communities, and building inclusive and just and welcoming communities is probably one of the best things we can be doing in the face of this crisis. We can continue, as I mentioned, to use our skills with code to help improve the situation. We can share data. We can continue to educate people. Think of the impact having hundreds or thousands more people educated in data analysis would have, particularly on some people in government who want to promote misinformation. As I say, we can share data. Behind me is from Brazil.io, where with a bunch of volunteers, they are able to get out a more complete picture of the virus situation in Brazil than I think the federal government of Brazil itself can. So we can continue to do that. We can continue to create services that help people find the resources they need, help people connect with others. We can help develop means of communication and sharing information. All of those things are things that we in the Python community are particularly able to help achieve. And I think that we need to do those things. And then finally, I think we can lead. And by that, I mean, we tend to have in the Python community the backgrounds that we can be informed citizens and we can speak out. I think that with our experiences in developing community as part of the Python community, we are particularly able to advocate for things that are good for communities in general. I think we have an appreciation of building community that is useful in a wider sense. Not to mention that the experience we have in organizing our Python communities is directly applicable to organizing other communities. If you can organize a Python meetup, you can organize a meetup of other people to work on other issues that are in your community. If you can bring together and organize a PyLadies chapter, then you know about building up groups of people and how to get people together, communicate, get the word out, all of those things. So I think we, as the Python community, are particularly well positioned to lead, to be at the forefront as we work through the changes that we are going to experience as we go through this. I think that can't really be emphasized enough, and I think that it is our responsibility to do that. And you know, I think I promised you I wouldn't come close to getting into the dinner time, and I'm going to keep my word on that. But I just want to say that, you know, we are facing times, I think, that will really reshape the world. And I think that the Python community, with its understanding of the importance of community, how to build it, how to bring people together, how to be inclusive, how to be just, we are going to be very important in how that gets shaped. And it's our responsibility to step up and do help shape it. Now, you know, I I don't know how profound or insightful any of this has been. I think sometimes it's important to just have someone say things, and I hope that that's what I have done here, is just say out loud some things that need to be said. And I guess, on that note, let me close here by saying one last thing that in my mind needs to be said, and that is, everyone, take care of yourselves and those close to you. Be safe and wear the damn masks. I don't want to lose a single one of you. So thank you, everyone. That's what I've got.
Thank you so much for that, Naomi. Some very poignant and salient thoughts for our era. I have a couple of questions here in Q&A. Would you be willing to answer those?
Sure, I'll give it a shot.
All right, so Oliver asks, he said, there are forces dividing, you said that there are forces dividing or endangering the community. Can you provide more details on that, please?
I think we're entering an age where we are going to have a rise in xenophobia and things like that. And I think we have had a rise in xenophobia. I think that directly works against our efforts to build a global community. If in fact you want to have someone from another country come and visit your conference, when we get back to that point where we having a government that is increasingly hostile to foreigners entering becomes a real drag on trying to bring people together. So I think, that's kind of an example. I think that even the divisions of opinion that people will have politically will be a force that will tend to drive people apart within communities. Not everyone in the Python community is going to agree on everything. And we're entering an age now where I think there's a lot more polarization and a lot less willingness to compromise and get along. I would say there are certain things upon which you cannot compromise, but the problem is when we enter such a stage of polarization, it becomes impossible to win anyone over. We simply enter kind of a fight to the death stage. So that makes it hard to coalesce a community.
So on that same note, I've got another question here, kind of on this idea of you mentioned coalescing a community. Trevin said, while many organizations, including EuroPython, have been able to shift to virtual venues, do you feel this will make it harder to form strong and diverse communities, as those who do not have internet access will not be able to participate? And how should we reach out to them?
I think in some areas that will be a bit of a problem. I think that over the past few years, we have done that access to decent internet bandwidth that would allow you to take part in something like this has increased, but it's by no means universal. There are lots of places where this is a problem. I think that will be a challenge for us. I don't have, honestly, some great answers. I know that bandwidth has been for a lot of communities a perennial problem. And it may be that some things like this will have to be rethought. I don't know if there's if anybody has tried having an audio only channel or not. One of my developers is in Lagos, Nigeria, and I know we sometimes have to kill video so that we can actually talk. And yeah, with the interaction you need to build a community, that is going to be a challenge.
And then kind of along those same lines, Thomas says, from a limited experience with the Linux user group, a mixed event, some people on site, some online, does not work that great. For example, audio is a problem. People on site don't share with the online people. Do you have a specific idea on how we can do that better?
Specific ideas, no. I think that the general thing is that we need to be aware of those issues and actually try to fix them. And I say that having had mixed remote teams as well, that just in that I've managed. It's really a challenge when you have half of your people in the office and half of the people scattered out remote, because there's always this temptation to turn around and say to the person behind you, oh, did you do this thing? And the remote people have no idea that's happened. So for conferences, we have the same challenge. I think people have made progress in just trying to delineate what the best practices are and how to get around that so that it can be improved. I also don't know that that differential will ever go away. But there again, that's something that as we move into this era and actually try to solve the problem, we may come up with better solutions than we've got now. But I think awareness and actually addressing it is the first step.
Awesome. Yeah, and I know we only have a few seconds left, but I feel like this last one's important. Nicholas said, how can we integrate the PSF more with Python communities that are not in the Europe or US?
I think one of the things that needs to be done is what I alluded to at the top of my speech, which is that we need to find ways to get people from those communities involved at a leadership level of the PSF. And I am no longer on the board, so this kind of gives me the luxury of shrugging and sort of ducking the whole thing, in that I cannot speak for the board. I know that they are passionate about addressing this. And I also know from my experience, because I've been around and I've met them all, that there are so many qualified people in all of these other countries, other continents beyond, right now the board is kind of strong on US, Northern Europe, Australia. There are lots of places where we have plenty of gifted people who would be great to have leadership. But as I say, I'm reluctant to speak for the board as to what that might be. I would expect it will go beyond just selecting people to be on the board of the Python Software Foundation. I think other things will be tried that will also help bring people into leadership of the PSF from around the world. That is my hope.
All right. Well, thank you very much, Naomi, once again, for that fantastic talk. I really appreciate having you here.
It was a pleasure.
And if anyone else has any questions for Naomi, please feel free to chat with her on Discord. So there's a whole room for this if you search for talk conferences during COVID-19. Actually, was that the one? No, actually, I wonder if we even have a breakout room for you.
Yeah, I think it's there. Staying for the community, I think, is what you would search for.
Oh, yeah, there it is. Talk staying for the community. Yeah, see, there's a similar talk, too. So it got lost. Okay, so it's talk staying for the community in Microsoft Breakouts. And if you have any other questions or want to discuss this with Naomi and everyone else, definitely pop in there. So thank you again. And we're going to be heading off to supper, or in the case of us Americans, we're going to be heading off to lunch. So we'll hope to see all y'all after that. So let's see, we are looking at 1930? Yeah, 1930 CEST. We'll be picking back up on our talks across all the different tracks. So check that out. We've got a lot of cool stuff coming up. So yeah, enjoy your lunch or your supper and stay tuned. And we hope to see you back here very soon.
We want to continue being the best audio streaming solution. But we were reaching the sort of tipping point where the current system wouldn't scale anymore. Thanks to Google Cloud, we've been able to scale it up to build the best cloud for us.
On est plutôt sur de l'open source tel que Hadoop,
Hive,
Spark,
Python,
Kafka,
Scala,
Java,
Scala.
MongoDB et franchement plein d'autres.
L'open source, c'est un miracle de la vie.
Utiliser la bonne techno pour le bon use case et ne pas forcément se focaliser sur une seule techno qui pourrait répondre à tous nos use cases.
Energy is part of our daily lives. But do you understand where it comes from, how it's transported, bought, sold, and the software that powers this? That's where we come in. Join the team developing the energy solutions of the future. Tradeport, where talented people never stop innovating.
Hi, I'm Diana, Python developer advocate at Vonage, and I want to tell you about our new Developer Champions program, Vonage Voyagers. Do you use Vonage APIs and want access to exclusive training, early access programs, and cool limited edition swag? Apply or nominate someone to be a Vonage Voyager now at developer.nextmo.com/Voyagers.
At Bloomberg, the success of our business relies on people like you who can look into the future and create groundbreaking technology, research, and expert insight to answer the world's most complex questions. We work on purpose. Ready to find yours?
We want to continue being the best audio streaming solution, but we were reaching the sort of tipping point where the current system wouldn't scale anymore. Thanks to Google Cloud, we've been able to scale it up to build the best cloud for us.
Oh yeah. Okay.
On est plutôt sur de l'open source, tel que Hadoop,
Hive,
Spark,
Python,
Kafka,
Scala,
Java,
Scala,
MongoDB et franchement plein d'autres.
L'open source, c'est un miracle de la vie.
Utiliser la bonne techno pour le bon use case et ne pas forcément se focaliser sur une seule techno qui pourrait répondre à tous nos use cases.
All right, I think we're about ready to get started here. So hope everyone had an awesome lunch or supper or whatever it is y'all were having. We're gonna be kicking things off here in just a minute with a talk by Jeffrey Mew of Microsoft. Speaking of Microsoft, if y'all haven't noticed in the track name, should probably mention that Microsoft is one of our generous sponsors that makes EuroPython 2020 online possible. They've got some really great tools for Python development. I can say firsthand, they're awesome because I do all my Python development in VS Code. It's a fantastic tool. So yeah, we got people coming in here, and so this is going to be great. So Jeffrey Mew is program manager at Microsoft, working on the Python data science and AI experience in VS Code, which means he's responsible for building some of the stuff I like. Specifically, he focuses on making the lives of data scientists easier across our ecosystem. He holds his bachelor's degree in computer engineering from the University of Waterloo. He's a lover of dogs and Python, the language that is. He's still a little bit unsure about the snake. Jeffrey, thanks for joining us.
Thank you for having me.
So where are you streaming from?
So I'm streaming from Seattle in the US, so it's actually in the morning for me.
Yeah, same here. I'm over in Spokane, so we're only about 300 miles apart.
Okay, really close.
Awesome. Yeah, is it warm there too?
Yeah, it's pretty good weather. That's what I love about the West Coast weather. Just really nice all the time.
Yeah, normally you don't hear people say that about Seattle, but we kind of like the rain, you know.
Yeah.
Sometimes. All right. Well, I will turn this over to you then, and rock and roll.
Sure. Thank you so much for having me. Let me just quickly share my screen. Oh, sorry. I need to give my computer permission to share screen before I can actually share screen. Sorry about that.
No worries.
Just give me 1 minute. Sorry about this.
It's at this point of the proceedings, I should probably ask if you have sacrificed a goat to the demo gods today.
Yeah, I think the demo will turn out well, but I just need to make sure okay, there we go. I just need to go into systems and unlock everything. Sorry, just give me 1 or 2 more minutes to do this.
No problem at all. Yeah. So, yeah, you know, computers can be definitely unpredictable things. I totally get that. And actually, tying back to what I was talking about VS Code a moment ago, actually, that's one of the things I like about it is that it usually just gets out of my way. You know, a lot of my IDEs tend to crash on me, but VS Code's been pretty stable. I've been using it for about a year now. So, I mean, hey.
Yeah, my computer just being very slow to unlock to give me permission. So I'm just entering my password right now, and right when I can click unlock, that's when I can actually zoom the permission to look at my screen.
Not a problem at all. Yeah.
But as this is happening, I can quickly just give an intro. So today we're going to be talking about how to supercharge your own data science workflow with Visual Studio Code, Jupyter Notebooks, and Azure. And in the context of this presentation, we're going to be building something called, we're going to be building like a pet breed detector. And while we're building this pet breed detector, I'm going to be showcasing off all the great data science features, data science and AI tools that we have in VS Code that we can use to leverage as we're building this feature, and also all the great tools that Azure has for us to host actually this detector online. So sorry, I don't know why this is not letting me share. Give me 1 or 2 more minutes. If not, I can. Okay, yeah, that might be useful. If it doesn't happen in 1 minute, then we might have to do that. I'm getting that spinner thing, you know, on Mac.
Yeah, I hate that thing.
Screen recording.
The spinning beach ball of utter doom. Basically what that is.
Okay, so it says, sorry, it says I need to quit Zoom before I can enable it to view my screen. Is it okay if I rejoin, or is there a process around that?
I think you should be able to rejoin. Yeah, that should be fine.
Okay, thank you so much. Yeah, I'll be
Heads
right
up, Simon. Thank you for putting up with our technical difficulties, everyone. But you know, it's like it's been running smoothly all morning, so something sooner or later was bound to blow up. This is just how things work in computers, as you know. It's like just when you expect everything to work really smoothly, it all goes kaput. So yeah, it's silent reminder while we're writing our code to trust nothing and verify absolutely everything. Test everything. So yeah, sooner or later, something is going to break, usually when you least want it to. But that's okay, you know. Flexibility is nothing we're used to. I have a thing around here somewhere for standby technical issues. Everything is on fire, but believe it or not, ironically, I can't find it. So you're just gonna have to look at my mug for a minute or two until we get this technology sorted. And there's Jeffrey again. So let's see if we can get. Or is that him? Is he there or not there? The promising sound of clicking. You got it?
Yes, yes. Finally, it's working. Thank you, everyone, for sticking through with this.
That's all right. Well, now, ironically, you only burned 5 minutes, so you're 7 minutes, so you're good to go.
Great. So can you see my screen right now?
Yep. You are great.
All right. So yeah, like I mentioned, we're gonna be talking about how to supercharge your own data science workflow with notebooks, VS Code, and Azure. And like Jason mentioned, my name is Jeffrey. I'm a program manager here at Microsoft, and I work on all the data science and AI tools within Visual Studio Code. And there's some of my contact info if you ever want to get in touch. So obviously, I just want to start with a quick demo of what we're actually building today. And along the lines, like I mentioned, we're going to be showcasing all the cool data science tools that we have in VS Code. So I've actually created this website, and it's already hosted in Azure Web Apps. And this is what our final product is going to be. It's just a website that it takes an image URL. It passes this image to my model that I've already predefined. It's also hosted in Azure, and it will generate the pet breed detector or give me a prediction of what it is. So I can just go to search for images of my favorite pet breed, which is Shibas, because they're so cute. Let's just pick this image. I can right click, copy image address, go back to my website, paste it in. It gives me a preview of what it is. And if I click submit, it actually passes this image to my model and it gives me a prediction. So you can see here, it accurately predicted Shibas. So this is what we're essentially gonna be building today. So how do we actually classify, how are we gonna classify dogs and cats, and more importantly, pet breeds? Well, it's really easy for us as humans to detect the difference between like certain, especially between dogs and cats. But with pet breeds, you can see between these two, it's also, it might be a lot harder for even humans. So to do this, we're actually gonna be training a computer vision model to do the same thing. So as humans, we've been trained to essentially tell the difference between these pet breeds and dogs, but we're gonna be doing the same thing with our computer vision model. So to do this, we're gonna be going through our traditional machine learning workflow. So this is something that almost all data scientists go through. So we're gonna start with our data exploration phase. So this includes things such as getting our data set, doing the data cleaning. We're going to move on to our training step, which is where we're going to actually create our training script. We're going to be doing this in Jupyter Notebooks and VS Code, defining some compute. So obviously, you probably don't want to run this on your local machine or it'll take forever. We're going to be running this on a more powerful GPU system. And then finally, we're going to actually productionize our code and deploy it to Azure in the cloud, like you just saw. I had that website hosted, and this is our final step. So the first step, like I mentioned, is data exploration. So to do this, we're going to be using something called the Oxford PET dataset. So it's a dataset from the University of Oxford. It has around 37 different categories of PET breeds and around 200 images of per class. So this is something we're going to be using in VS Code. So we're going to go back into our demo. We're going to go into our favorite editor in IDE, Visual Studio Code. So to actually get, you can see here, this is the notebook I've already created, but to get the data science features within VS Code, you'll obviously first need to install Visual Studio Code, which is completely free and cross-platform. So work on Mac, Windows, and Linux. And the more important thing is you need to install the Python extension because that is where all of our data science goodies are held. So to do this, you just quickly click on the extensions tab and then search for the keyword Python. And it should be the first one that pops up and authored by Microsoft. And then you can quickly install it. I've already installed it for the sake of this demo. But once you actually have it installed, you'll see this start page appear and pop up. And here you can just do things like if you want to create your own notebook, you can do it. But I already have an existing notebook, which I can click on this to create and to open up an existing notebook, and open up in what we call our notebook editor. So this is a brand new feature that we released near the end of last year. And you can see it's your traditional Jupyter Notebook UI type view. So you have your cells, you have your input and output. So if you have any output cells, it'll show below. You can have Markdown and everything. And what's really great about the notebook editor in VS Code is that it combines the flexibility of Jupyter Notebooks as a data science or just Python editing tool in general. So because you can run cells out of order and everything, but with the power and of VS Code as editor IDE. So one example of this is you have full and IntelliSense and autocomplete support within within your cells in VS Code. So if I want to do, for example, import pandas as PD, and then I can type PD dot, and then it will actually, you can see a lot of these auto completions are popping up as I'm writing it. So if I want to also do OS dot, it gives me the top suggestions of what it thinks I want to do with this package OS. So if I want to, I don't know, make a path or something, I can type that as well. And then it gives me these suggestions, which is really great because traditional Jupyter Notebooks often doesn't support this. Great, so now we can, the first step, like I mentioned with the data exploration, is actually importing our data set into our local machine. So to do this, I have this cell. So the first cell is just some generic imports I needed to do. But the next part is actually importing the data set onto my machine. So I have my data set URL, which is pointing to that same Oxford data set. And I've written a bunch of helper functions, as you'll see throughout this presentation in my notebook, just to clean up the code a little bit. So you don't have to worry too much about the code, but if you're ever interested in learning more specifically of how all the code works and how these helper functions, or what these helper functions actually do, I'll be including a link at the end of my demo, or at the end of this talk to the GitHub repo, so you can actually look at the code yourself in your own time. But in this code, all it's going to do is it's going to download this data set, and it's going to save it into my local workspace. So you can see here, if I go to my files tab, if you can see I have this images subfolder. So I've already run the cell just for the sake of time. I've already pre-downloaded it, and it's separated into its training and validation step. And you can see all the different pet breeds are here. So once we actually have our data set downloaded onto our machine, one thing we want to do as a traditional data scientist, you want to actually make sure that that data is correct. So just do a sanity check. And to do this, I've written this really simple function using matplotlib. And what the function does is it will just plot random samples of each of the categories of images. So you can see here, I can just do a quick sanity check to make sure that these images look right. There's no like really weird images. There's no images of, I don't know, maybe like a snake or a pig. So we can make sure that these images are correct. But another really great way is we also fully support custom IPy widgets. So you can see this plot using matplotlib, which is a really great library. You can see it's really static. There's no real interaction with it. You just look at it. But with IPy widgets, if we run this cell, IPy widgets are essentially a more interactive plotting or interactive experience. So you can see here, if I want to look at my plots or my training images more interactively, I can actually scroll between and look through the different, look through my different pet breeds. So it's kind of like a more customized interactive UI. And we fully support this within VS Code as well. Great, so now that we've actually imported our data set and then quickly looked through our data set to make sure that all the data is correct, now we can start transforming our data into tensors. So like I mentioned, we're going to be doing this pet breed detector, and to train it, we're going to be using something, we're going to be using a Python framework called PyTorch, which is a really popular deep learning framework. But PyTorch doesn't actually understand these image files. It needs to actually be converted into something called tensors, which you can just think about as matrices of numbers. And we need to convert them to tensors before we can actually pass it to the model, sorry. So to do this, usually we just want to apply some transforms. So here I'm just cropping them because all these images can be different sizes. So I want to make everything uniform and standard before I pass them to the model. I'm going to crop it, apply some transformations, and then convert it to a tensor. So I can run the cell by just clicking this run cell icon, or I can actually run the cell by, we fully support Jupyter hotkeys as well. So if I want to use my shift enter, I can just type shift enter and it'll also run the cell as well. So with these transforms, it's often really easy to make a really quick mistake, or it's hard to tell. It's really easy to make a one-off error because these are just numbers and you're just applying these transforms. So a really great way to check to see if these transforms are actually performing properly is with the feature we recently added called run by line. So you can think of run by line as a simplified notebook debugging experience. So what this means is that, I'll just show you with the example. There's this run by line icon here, and what run by line does is it steps through your code line by line and gives you a state of all, it shows you a state of all your variables at each line of code. So rather than having to write print statements between all these, so maybe you have to write print image.shape, instead of having to do that and having a bunch of print statements and just generally taking up more time, you can actually run you can run by line, and it will actually showcase, you can see it's stopping at the first line of code, and it'll step through each of the lines of code and tell you the state of all your variables. And it actually showcases the state in what we call our variable explorer. So if you can see, I open up the variable explorer at the top of my notebook here. And I wanted to look at the variable image because that's the one I'm most interested in. So if I look at image, you can see right now it's just a JPEG image file because in the previous cell, I just opened up a random sample image just to test to see if my transforms are working. So as you can see, if you pay attention, let me just make this bigger because I zoomed in on VS Code just so everyone can see better. But you can see image right now is around 500 by 375 pixels. So if you remember, the first step is I crop it to 224 by 224. So you can see as this is running, so you can see now the size is 224 by 224. So you can see the crop actually worked. And I can continue to step through my code. And if there was an error, it would just stop and tell me there's an error. But so far, there's no errors, which is great. Then I next transform into a tensor. So you can see the image afterwards, it transforms. You can see now it's a tensor type before it was an image type. So now I know that this tensor transformation is actually working. And then finally, at the end, it just finishes. And it knows that because I got no errors and everything looks right so far, that I can now apply this transformation to all my images. So I just wanted to test on one image before I did on everything. Great, so let me just close up my variable explorer again. And the next line is where I'm actually, I've written this function previously to just do the same transformation, but instead of just that one image, do it on all my images in my data set. Great, so now we just did the data exploration phase. So like you saw, we imported our data set, we did some data cleaning where we quickly checked all our data within our matplotlib just to see if everything looked great. And then we converted everything into something that the computer and more importantly, PyTorch will understand when we do the training step. So now we're gonna actually head to the training phase. So again, we're gonna go back to VS Code for this. So in the training phase, we're actually, all we're doing is we're applying something called transfer learning. And to do this, we're just taking a pre-trained neural network. So we're taking something called ResNet 18, but we're actually just setting up the model within VS Code. This is all from PyTorch as well. And we're going to actually train the model. So I've already written this training function. And again, if you want to learn more about how this training function works, please check out the GitHub repo at the end of this presentation. But for the sake of this demo, I'm just trained it for one epoch. And you can think of epochs as iterations. So the more iterations you do, generally, the better accuracy you're going to get. So I only did it for one just to show a proof of concept. But you can see after training it for one iteration, essentially, this kind of took 40 minutes almost to run, which is extremely slow because I'm running it just on my personal laptop. And I think we can do a lot faster than this. So to do this, we can actually leverage something called Azure VMs. So Azure VMs are actually, we can leverage Azure VMs because they have GPU compute, and this is where these deep learning models actually thrive. So to do this, I just need to actually download this Azure VMs extension. So I can search Azure Virtual Machines. And then you can see here, I already have it installed. But once you actually have your Azure Virtual Machine, this extension installed, you can quickly go into your Azure tab. This Azure tab will now pop up. You can go into Virtual Machines. And then you can see I've created a virtual machine already for EuroPython. And then what's also great is VS Code has really great remote SSH support. So you can actually connect to remote machines and then do everything you're doing live on that the same thing that you're doing on your local machine on that remote machine. So what we're actually going to do is we're also going to install the remote SSH extension. Okay, the remote SSH extension. And then from here, we can actually connect to, you'll see this button up here, and then you can actually connect to your remote machine. And I already have this set up, but for the sake of time, I'm just gonna quickly skip over this. But this will just pop up a new VS Code window. It will look the exact same thing as this, as you saw already, but it's now gonna be running on your remote machine. And then on that remote machine, I ran the same training, the exact same code, the exact same file, but I ran it and it's actually got the same accuracy. Might be some errors with my connection, but I got the same accuracy, but with I ran it for 10 iterations, sorry. This is only one, so it took, on my local machine, it took 40 minutes to run one iteration, but on that remote Azure machine, it actually took around 15 minutes to run 10 iterations, which is insane about how much of a speed up I got from using the remote machine versus my local machine. So now that we've actually trained our model, we actually need to save our model, which is the final portion. So I just have this basic function which just saves the model. And once we have the model saved, we can start deploying it to the cloud. So now we're actually we've completed our data exploration, we've completed our training, and now we're ready to productionize our model. So to do this, we have this really great feature that we just released recently called Gather. And you can see the button for Gather right here. And Gather is essentially a dependency analysis and code cleanup tool. And what it does is it will just look through all the code in your notebook and look through all the cells and all the code and only extract the relevant code and lines of code, only extract the relevant cells and lines of code that are required to generate the cell. So if I click on this button, it will just give me a new file called the Gather notebook. And you can see it only contains the code that is required to generate my model. So you can see it only contained the data set, transforming the data and the training. And it left out all these plots because it realizes these are just intermediate steps that were not needed. It left out a bunch of my markdown cells because that's not needed as well. And it left out a bunch of imports. So you can see it only kept the key imports as well. Finally, I just need to move this, sorry. So finally, once you're actually in this Gather notebook, to productionize your code, instead of you usually want to convert to a Python script, because you can't really do much with a notebook to deploy. Instead of having to copy and paste your code over, you can actually, we have a feature called export, where you can just quickly export as a Python script, and boom, it's now a Python file where you can start refactoring your code and change it into something that you can basically refactor it and get it ready for production to deploy to the cloud. So speaking of the cloud, we're going to get to the deployment step now, where here's the outline, which is just showing you how we're going to use this. So previously we used VS Code and Azure Virtual Machines to leverage the compute, but now we're going to actually make use of these three Azure functions called Azure services, sorry, called Azure Storage, Azure Functions, and Azure Web Apps. So we're going to be using Azure Storage to actually store our model because we want it to be kind of like a microservice where we don't have to update the entire web app each time. We can just upload the model directly to here, and our API or whatever will read from this this microservice. The next step is we're going to be using Azure Functions. Okay, we're going to next use Azure Functions, where Azure Functions you can think about as an API service, and this is where we're actually going to host our API endpoint for the model. So this is where the website's actually going to call it. And finally, we're going to be using Azure Web Apps, which is the front end. So that's the front end we saw at the beginning of the presentation, the demo, where I hosted the website where I actually did the prediction of the pet breed. And what's really great is because Azure is so tightly coupled with VS Code, I can do everything to deploy from within VS Code. I don't need to go anywhere else. So again, to do this, I just need to install the relevant Azure extensions. And again, these are all completely free, these extensions. So you can just, you can see I already have them installed. So I have Azure App Service, Azure Functions, Azure Storage. And the first step, like I mentioned, is I want to deploy my model to the storage. So if I just open my storages tab, I can see I have I want to create a container to actually store my model. And I've already created a pet detector, but if you want to create your own, you can just right click and click create. And to deploy it, you just right click and click upload blockbob. And then from here, you can quickly scroll to where your model is. So I have my model folder right here, and it's a checkpoint.txt because that's what TensorFlow saves it as. And I can just quickly click it and then click upload. But again, for the sake of time, you can see if I've already previously uploaded this. Once you click upload, it'll show up here. So now that I have my model in storage, the next part is actually creating my API endpoint. So to do this, I will go into my functions tab, and I'll create a new function. And you can see if I go into my folders, my functions actually contained within this inference subfolder. And you can see there's kind of a lot of files here. It might seem a little bit daunting, but what's great is with this Azure functions extension, you can just click this one button here, which creates a new project. I can define where I want it to be. In this case, I created the inference one. And here's where it automatically generates all these files for me, so I don't need to do anything. And this predict.py is the only thing you need to create. So when you actually create the template, it's kind of blank. But once this is where you're actually editing to make your custom API. So you can see here, this is where I'm actually just getting the image URL. And it's passing it through the model that I'm getting from Azure Storage. And then it's returning a response of what that prediction actually is. And again, once you have your Azure function created, you can quickly just deploy it by right-clicking my Azure function, click deploy to function app, and it'll just deploy to that function app. Again, I've already deployed it for the sake of time. And again, you don't have to worry too much about the code. I'm going to be linking the code at the end of this presentation if you want to take a closer look on your own time as well. Finally, the last part is app service, where we're going to be hosting our front end. So here is where we're going to be hosting that front end. I just created a basic, I just created a basic HTML file. That was what you saw earlier for this. And this basic HTML file, all it does is it just calls my API that you just saw previously on my Azure functions, and then just returns the result. And again, super simple to deploy to this. I just go to my Azure tab. I can right-click, create a new web app, but I already have one here called JME PyTorch web app. All I need to do is just right-click, deploy to web app, and then just point it to that website. So I have this website, and then you can see this folder. All it contains is that index.html, just one file. Click select, and then it'll deploy to the cloud. So those were how, and as you can see, all this was done within the context of VS Code. Great, so I'm just going to quickly jump through a quick summary, just because we're running low on time. Yep, so we started off with our data exploration. We did this with the Python extension within Visual Studio Code. We next went through our training. So we stayed within Visual Studio Code, but we used Azure virtual machines for the compute. So that's where we leveraged our GPU compute to speed things up. And then finally, to productionize our code, we used our different Azure services. So we used, you can see Azure Functions as the API, Azure Storage to store our model, and Azure Web Apps to actually host our front end. And the key portion is this was all done within VS Code. So this is why VS Code is so great. It has all our data science tooling and needs, and I didn't have to leave VS Code for anything. So what's next? Here's just the link for the GitHub repo if you're interested as well. And as well, if you want to try our VS Code notebooks, you can just go to aka.ms/notebooks. So these are the only two links you need to remember if you want to remember this presentation. And that was it. Thank you for putting up with the technical difficulties in the beginning, but thank you so much for your time and listening. I'll leave the slide up if people want to take notes as well. Sorry, I think you're muted.
Oh, thank you. I'm sorry about that. Thank you so much for that. So Microsoft, Harry has a question. He said, Microsoft has announced the Azure notebooks will be discontinued soon. Is the VS Code editor recommended to replace the Jupyter IDE?
Mm-hmm. So the Azure Notebooks service is being discontinued, but we're replacing it with something called the Azure Notebooks component, which is going to be basically a version 2 or a better version of Azure Notebooks, but embedded within different components of Azure services. So one example could be like within Azure Machine Learning. But I would say that code spaces, that's something I forgot to bring up because I didn't have time, but I can quickly show it right now. I don't know if I'm still sharing screen. Yeah, but there's a thing called code spaces, which is VS Code in the browser. And this is a really great alternative to Azure notebooks, which you just have the same notebooks experience that you just saw in VS Code, but now it's within your browser and within a virtual machine. So just call it code spaces.
Awesome. Well, thank you very much. Okay, so we're gonna go ahead and we got a quick word from a sponsor here, and then we're gonna have Dustin Ingram up next for all of you who are waiting for his talk. So thank you again, Jeffrey. If anyone wants to chat with him, he is available in the in his breakout room, which there's a link to it in the Microsoft track, but it is Talk Supercharged Data Sci Workflow. So without further ado, then just a quick word from our sponsors. Then, if you give me just a moment, that technical glitch, we are running slightly behind, but we will make up the difference in a moment here. So hang tight with me, Dustin. You're up next. So.
Et en fait, chez Numberly, on a énormément de données, on a des vrais use cases, on a une vraie maturité sur les projets sur lesquels on travaille.
Dans une seule journée, on peut toucher à 3-4 technos différents. Côté, je vais jouer avec des nouvelles technos.
Il y a une vraie entraide entre les différentes personnes de Numberly, quelles que soient leurs équipes. Et ça, c'est super, je pense.
So, yeah, thank you to Numberly and Microsoft and all our fantastic sponsors for making this possible. So next up, we have Dustin Ingram. He's a developer advocate at Google, focused on supporting the Python community on Google Cloud. He's also a director of the Python Software Foundation, a maintainer of PyPy, and an organizer for the PyTexas conference. Welcome, Dustin Ingram. Very glad to have you here.
Thanks, Jason.
I could probably guess for that intro, but where are you streaming from?
I'm based in Austin, Texas.
Austin. Is it hot and sunny there?
It is right now. Yeah.
Awesome. Well, I will turn it over to you, and awesome.
All right, let me share my screen. Is that look good? Okay. So hey, like you said, I'm Dustin. I'm a developer advocate at Google. I am a director for the Python Software Foundation, and I work on PyPI. I'm not here to talk about any of that today. I'm here to talk about static typing in Python. So quick pop quiz, is Python dynamically or statically typed? And so sort of think in your head, maybe what is the answer to this question? So the answer is that Python is dynamically typed, but it can optionally be as statically typed as you want it to be. And so that answer might not make sense to you even if you've used Python for a while, or if you are familiar with other static languages. And that's okay. That's kind of the point of this talk. We're going to talk about what that means. And so the steps to understand the answer to that question are sort of this. We need to talk about types in Python, just regular types, type systems in general across other languages. We'll talk about dynamic typing in Python, and then finally we'll be able to talk about static typing in Python. And once we understand those things, we'll talk about how to use static typing, when you should use it, and maybe sometimes when you shouldn't use static typing. So let's talk about types, and specifically let's talk about type, the built-in keyword in Python. And you might be familiar with this. So type tells you what something is, what an object is, or what a variable is. So if I call type 42, Python will tell me that it is class int. So I know that that's an integer. And I can do the same thing with floats and strings and lists. So you might say, okay, I recognize these as built-ins. They tell me what types things are, but I can also use them to change types or do sometimes what we call type casting. And you'd be right? I could take a variable a, and when I assign it to the value, we say that a is a type of an integer, and I could cast it. I could use that float built-in to turn it into a float, and I could use a string built-in to turn that into a string, and I could use list built-in to turn that into a really ugly list. So I imagine some folks watching might have had a weird bug where they accidentally got a string turned into a list. And guess what? That is a type error. If you've experienced that before, you're definitely in the right place. So why does Python let that happen? So it would seem like these are the only types that are available to us, right? The things that we can cast from one type to another. But these are actually just classes that happen to have corresponding built-ins in Python. So basically it's kind of just doing class matching here, right? We can say whether the number 42 is an instance of the class int, and when we call type, it gives us that same class back. So it's sort of this just a class, and it's a sort of a shortcut or an alias for that class name. But there are other class types as well that don't correspond to built-ins. So for example, none, we've all sort of used the none built-in, and we've seen none type before, but they're not the same. Similarly, for a function, we don't say, when we initialize a function, we don't instantiate a class, we say def func, but that has a class underneath it too. There's a function class. And same for ellipsis and actually lots of other things as well. And the place where you can sort of find the classes that represent all of these things in Python that we might want to interact with is from the types module. So you can import types, this comes with Python, and you get a whole list of different types of types. And the kind of fun thing about these is if you wanted to, you could instantiate a class with a function type and put things inside it, but actually that gets pretty long and verbose, and it's a lot nicer to just write normal Python. So when we say the Python is a dynamically typed language, what we mean is that a variable, once it's defined, can be any type. We can initialize the variable, we can set it to be one type, and we can change it. So for example, what type is A here, right? I'm importing random, and I'm taking a random choice from this list. And that list includes an integer, a float, and a string. So when I call type of A, this could be anything. It could be any of those three types that I put in the random options. And so it could be a string, it could be an int, or it could be a float. And Python doesn't care. Python lets us set A to be any of these value types, and that is what we mean by dynamic typing. This means that arguments and return types of a function can also be any type. So the same is true for a function as it is for variables. The things that we return from functions or that we pass to functions, they can also be any type. So in Python, when we write a function like this, how do we know what types this function is expecting, right? So if you saw this function somewhere and you didn't know what it does, what would you expect the argument types and the return type to be? So you might say, okay, well, I'm seeing that it's adding things together. So maybe these are integers, right? And you'd be right. You could call this frobnicate function with integers, and it would give you the sum of all those integers. But you could also call frobnicate with strings, and it would concatenate the strings into a single string. And actually this works for lists and really anything else that would support this addition operator in Python. So we can say that the arguments to frobnicate and the return type of frobnicate are dynamic. And then this can cause problems though, right? Because if we don't have any way to sort of guarantee what the arguments are, we can have type errors. So for example, if I call it with two integers and a string, we can't do this because the addition operator doesn't let us mix types like this. And so we get a type error because we're trying to combine integers and strings together in the body of the function. All right, so that's pretty confusing. How could we fix it? So one thing we could do is write really long and detailed doc strings about what the function expects and what the function should return. And this is great for developers, and sometimes we do this. I don't do this. This is a lot of work, and it's a lot of work to maintain this documentation. And on top of that, writing these comments, while they're helpful for developers, doesn't actually guarantee that someone using your function is calling it correctly, right? These are just sort of like when you're reading the source code, it tells you how to use the function, but it doesn't give you any guarantees at all. One thing that could give you some guarantees is if you assert it on the type of every single argument and of the return type every time this function is called. So I can assert on A, B, and C that they're integers. I can do my business logic inside the function, and then I can assert on what the return type is, and then finally return it. We don't usually do this either. What we usually try to avoid this for is because every assertion here is just a little bit of overhead, right? It's another line of code we have to run. It's an extra check, and actually this can also be wrong, right? It's sort of dependent on whether the developer has written the assertion correctly or remembered to add the assertion to their function. So there's things that could go wrong here as well. And we don't do this very often. So what do we do instead? So instead, in Python, we do something that we call duck typing, which is that if it walks like a duck and it quacks like a duck, it is probably a duck, right? We rely on how the variable is used to sort of determine what type it should be. And so for some examples, in each of these, you can kind of guess what the variable bar is based on what is being done with it. So in the first one, you can tell we're iterating over it. So it's probably like a list. Could be a string though, it's hard to tell. In the second one, we're comparing it to 0 with the greater than operator. So bar is probably some kind of number like an integer or a float. And in the last one, we're calling it, right? But it's kind of ambiguous. In the last one, it could be a function, it could be a class. I don't know what I'm going to get back for foo in each of these. So it could be anything. And yeah, the ambiguity here, if we wanted to reduce that ambiguity, is what static typing would give us. So static typing means that the variables and the return types and the argument types of a function are defined and they will not change. So there are actually lots of statically typed languages. I want to show you some examples real quick, just so you can see what they look like. This is C. This is the same from the key function, but written in C. So you can see that it's declaring int for the return type and int for all the variable types. This is Java. It's pretty obvious if you've used Java before, because Java has this public static int incantation at the beginning, but also declares argument types to be integers. This is Rust. So Rust has really fine-grained control of the integer type. So that's an unsigned 8-bit integer that it's accepting and returning. And this last one is TypeScript. So in JavaScript, JavaScript doesn't have static types, but there's a variant of it called TypeScript. And in JavaScript, all numbers are the same thing. They are a number. So in TypeScript, there is only the number type. So everything past this argument or this function is the number type. So we can sort of put languages into two categories, dynamic and statically typed. You can see that Python, right in this slide, is in the dynamic category, and things like C and Rust and Java and TypeScript are in the static category. But we have to put a little asterisk here because Python is kind of an odd duck, and we can do static typing with it as well. And technically Ruby is going to get something very similar to Python at the end of this year, I think, last time I checked, but for now I'll leave it in the dynamic column. So like I said before, Python is dynamically typed, but can optionally be as statically typed as you want it to be. So this wasn't always true. And the story of how Python became a language that can optionally be statically typed is also kind of the story of static typing at Dropbox. So Dropbox is a large Python shop. They use a lot of Python. A lot of Pythonistas work there. And there were some things sort of in their journey from going from untyped to typed Python code that led up to static typing as we know it in Python today. So I'm going to give you just a quick overview of everything, sort of the progression of static typing and how Dropbox is involved and that kind of thing. So in 2006, we had a PEP 3107. This came out in Python 3, and this allowed us to do something called function annotations. So it allows us to take a function like this and add basically any metadata that we want to argument and annotate the arguments and return values. So the thing to know here is that this has zero effect on the execution of the function, but what it gives us is a nice little attribute on the function of the annotation. So it will actually evaluate the annotations, put them in this nice little dict based on the variable and the return type. I'm not sure what would happen if you were passing an argument named return. I guess maybe that's probably not frowned or is frowned upon, but you would get this annotations dict, and that would, anything that was sort of putting together this function would have access to these annotations. And so this is interesting. And the PEP included a bunch of ideas about what this could be used for. And they all kind of boiled down to typing and then maybe some other stuff like documentation. So this allowed us to write a function like this if we wanted to do, evaluate typing with it. I could, as the annotation, pass this class or the keyword that represents that class. And then when I access the annotations, it would tell me what I had written in my source code as the annotation for those variables and the return type. But that's all it gives us. It doesn't give us a way to evaluate whether this function was being used correctly or whether these return types were actually being returned. And it only gives us a way to annotate functions. It doesn't give us a way to annotate any variables or anything that might be used within the function or outside the function. So around this time, Yuka Tassilo was working on his PhD research at the University of Cambridge, and his research was about the unification of a statically typed and dynamically typed language. And he wanted to use the same language for everything from a tiny script that doesn't need static typing to a sprawling multi-million line code base. And he was also focused on the gradual growth. He wanted to be able to slowly migrate from an untyped prototype to a statically typed product. Everything from, take that little script and slowly migrate it to something that was large and statically typed. And this is the idea that you basically don't have to do it all at once, right? He wanted to be able to make static typing completely optional. So he published his thesis in 2011, and it said something basically along these lines. He found that adding a static type system to a dynamically typed language can be a really invasive change, or would require coordinated modification of the programs, virtual machines, development tools, basically everything that the language touches would have to be changed. But he found that adding an optional pluggable type system would not affect the runtime semantics of the program and could be added to a language without affecting the existing code or tools. So this sounds really great. It sounds great for Python because we're already set as a dynamic language. Being able to statically type things optionally makes a lot of sense. So at 2013 at PyCon US, he introduced something called MyPy. So if you've heard of MyPy before, what he introduced was not exactly what you might think of MyPy. At the time in 2013 when he gave this talk, MyPy was described as an experimental variant of Python that supports writing programs that mix dynamic and static typing. So in his research, he wasn't able to use Python as the language that he was using to do his research. And so instead he created his own sort of variant, which he's doing research, so it sort of makes sense that he could create a variant just to sort of prove his theories. His variant looked like this, and this, he actually called the variant MyPy. And the variant looked like this. You can tell it kind of looks like Python if you squint at it, but there's some other stuff happening here. Like you can see where the function fib is being declared as an integer, and the argument type kind of looks like a function annotation that we were talking about before. So it kind of looked like Python, but wasn't Python, but you could compile it to Python. And so the issue was that even with the function annotations, Python couldn't support everything that was necessary to be statically typed. And so what happened? He presented this at PyCon and he talked to Guido afterwards. And Guido said, basically, let's drop the custom syntax, let's drop the variant on the language, and let's just do this in regular Python 3. So MyPy also included a type checker for the variant, and that is actually what we think of as MyPy today, and that since it was now modified to check Python itself. So in 2014, we got PEP 483. This is a theory of type hints, and this is basically Guido putting down his ideas about how static typing should work in Python. And his ideas sort of aligned pretty well with what Hugo was working on. So he said that typing should be optional. Adding annotations shouldn't affect the runtime of the program, shouldn't get in your way. An annotated function should behave exactly the same as an unannotated function. And I think this was probably had a lot to do with the lessons we learned from the Python 2 to 3 migration. We wanted a adoption of static typing to not be a breaking change, not require a huge migration, that kind of thing. He wanted it to be gradual, and this allows us to annotate only one part of a program or even just one function of a program and sort of leverage the aspects of both dynamic and static typing together. He wanted to add variable annotations so we could annotate more than just a function. And so that means that we could do something like this. Instead of having our variable bizbaz be unannotated, we could add a comment like this, called a type comment, and this sort of gives us a type annotation for that line without changing the Python syntax. And he wanted to be able to support type hinting for Python 2 because function annotations only existed in Python 3 at the time. So he wanted it to be possible for even the people stuck with Python 2 to continue to be able to adopt static typing. So that means that in Python 3, we could write these nice function annotations, but in Python 2, we could fall back onto these type comments, even for the function definition and that kind of stuff. He introduced some special type constructs, which were sort of building blocks that we could use to define types. So that, adopted all the existing types like int and float, and then created some new types that come from the typing built-in module. Like any would be a wildcard for matching any type. Union would combine two types together into a single type. Optional is the union of none and basically any type that you want. Tuples, subtypes for collections, that kind of thing. So that would let us write a function like this. Once we have special type constructs, we could say that the last argument to this replicate function could be an integer or it could be a float, but the first two have to be integers. And then we could similarly define the return type to also be the union of int and float dependent on what was passed into it. It also defines some container classes. So these are things like lists and dictionaries. So we can type the keys or values of a dictionary, for example. So like I could define a list that contains all integers, and trying to append a string would fail. I could define a dict that has a key of a string, value of an integer, and similarly, trying to go against the typing would fail the type checker. It also introduced some generic types for when classes and functions behave in a sort of generic way. So we could do things like this, just say that work accepts an iterable, gave us some aliases as well. So if we wanted to, we could union all the numbers together into a single number class and be more like JavaScript. And next in 2014, we got type hints. And this was given to us in Python 3.5, which was released with that support. We got syntax for variable annotation. So that let us go from the comment style syntax to pure inline Python. We could annotate variables. We could initialize variables with types without actually having to give them a value. Similarly for classes. In Python 3.6, we got PEP 526 support, which almost had everything we needed. Last thing that we needed to finish the puzzle was a type checker. So the difference between type checkers here is static and dynamic. So MyPy at this point had fully transitioned to a static type checker. That means it's going to check all of your code at rest. And it works kind of like this. You would install it from pip, you would create a Python file, okay, and you would define a Python file and then run MyPy on it, and it would tell you when you're using types correctly or incorrectly. So at this point, there are actually lots of static type checkers and dynamic type checkers as well, which would check your types at runtime. So basically all the big Python shops had their own type checker. And still do actually. So Dropbox basically owns the development of MyPy. Google has a tool called PyType. Facebook has Pyre, Microsoft has Pywrite, and actually some editors have type checkers built into them like PyCharm. And then yeah, there's a bunch of dynamic type checkers as well. I think those are not quite as popular because they do add a limitation at runtime. So one of the questions I get a lot about this are the differences between the static type checkers, because if they're just implementing the standards, like what could possibly be the difference? Maybe one's a little bit faster than the other. So I'll talk about the big sort of philosophical differences between MyPy and PyType, which I'll call cross-function inference and runtime lenience. And these are sort of comes down to a difference in philosophy about the behavior. So for cross-function inference, here's an unannotated file. And if I were to run this in Python, I would get a type error, right? Because what I'm trying to do here is concatenate a string with an integer, and that would fail. So just executing Python, I get a type error. If I run this through MyPy, it actually succeeds. It doesn't tell me there's anything wrong here. If I run it with PyType, however, it will give me an error. And the problem is that MyPy doesn't have the ability to infer types across multiple function calls, and PyType does. So PyType says, well, that's going to be a runtime error. We need to raise an exception or fail the type checker here. Similarly, another difference in philosophy is sort of whether functions that succeed at runtime should be type errors or not. So in Python, I can annotate a list to contain only strings, but then it's totally valid to append an integer to it. That won't actually create a type error in Python. And so if we run this, it works just totally fine. If we run it with PyType, it says there are no problems. This won't create a runtime type error. MyPy is a little more strict though. It will say, well, you define the type for that list to be a integer and a string, and you try to put an integer in it, so that will fail. All right, some more questions. You might just be saying, all right, why? Why and when should we use static typing? So first I'll talk about when you shouldn't use static typing, which I think is basically never. I think static typing you should just use at your leisure or as liberally as you want. You should be able to experiment with it. One thing I'll note is that static typing is not a replacement for unit tests. And there is a bit of similarity here. Sometimes unit tests end up looking a lot like type checking. You sort of pass certain things in and assert on the output of the function, whether it errors or succeeds. But really, unit tests are just a bad type system. In reality, you probably should do both. So when should you use static typing? Basically, use as much as possible. Use it whenever you can. You should definitely use static typing when you're millions lines of scale. So if you're Dropbox or Google, you've probably already invested a lot in static typing in Python. And actually, Dropbox found that at their scale, dynamic actually was a liability for Python. It made it really hard to understand how functions and how a code base would work, and began to impact productivity. So all those companies have invested a lot of money in the work that was already done here. And the lack of typing, you can think of it as a liability once you get to be that big. Made a little handy graph. So the time to start thinking about static typing is not when you're the size of Dropbox or Google, but sometime before that. So you're probably here. This is when you should start thinking about adding type annotations. Here's when you'll probably actually do it, but that's okay. You can gradually add it as you go. You should also use static typing when your code is confusing. So let's be honest, we've all written confusing code before. Some people like to say that annotations are machine verified documentation, and that's true. If you feel like you need to document a confusing function, specifically the input output types of it, for example, you should probably just statically type it, because that will be just as clear, and then you can do static analysis on it as well. You should also use static typing when your code is for public consumption. For example, if you're going to put it on PyPI as a module. So adding type annotations helps third-party developers that want to use your module know how to use it. It also lets IDEs do auto-completion and tell you how to consume the API. And then if your users are already using static typing in their code base and they want to pull in something from your library, they will absolutely love that you support static typing as well. Another place that you can use static typing is before migrating or refactoring. So before you make a big change, go and add some static types, move things around, and see if any of the typing breaks. That's probably a bug. And finally, you can use static typing just to experiment with static typing. It doesn't hurt, it's totally painless, and it's just be a fun way to learn about a new part of Python. So to wrap up, how to use static typing in just 5 easy steps. First, you have to migrate to Python greater than or equal to 6. Now this is actually optional. You can use type comments in any version, but let's be honest, you should migrate to Python 3 anyway. Install type checker locally. I don't care which one it is, but install it and integrate it into your editor so that it runs automatically when you write or save a file. And then you can start optionally typing your code base. Start with the most complex function or the easiest to understand function. Don't try to do it all at once. Remember, it's intentionally a gradual process, and pick sort of critical areas and start there. Second to last, run the type checker with your linting, put it in CI and have it just run there anyways, assuming that you have CI. And finally, convince all your coworkers to join you. So if you need help convincing them, feel free to send them my way. Thanks everyone to the talks. And I want to give a quick shout out and thank you to the organizers as well. This has been really amazing, seamless online conference. And they absolutely deserve your thanks as well. So thank you everyone. Thanks for your attention.
Absolutely, thank you so much. I am supposed to be able to play this. I'll open the door and let the audience in. So yeah, so I have one question here. Oh wow, actually this has gone up to 5 in the last few seconds, but we don't have time for 5. We'll do as many as we can. So anybody, if we don't get to your question, look in Discord for talk static typing. You can talk to Dustin there some more. Yep. But let me see here. So someone said, is there any tool which can build API docs of the return types of each function by extracting static type annotations from your Python code?
So you're saying automatically building documentation from static type annotations? Yeah, I think there's some stuff that exists, and definitely there's a lot of the documentation tools now will take into account whether you have statically typed functions. You don't need those long doc strings that I was showing in order for your API documentation or your module documentation to pick up and show what the expected values are for this one. So I haven't actually used any of them personally, but yeah, I imagine that some of the more prominent documentation tools definitely should be supporting that. Yeah.
Okay, Francesco asks, how can one combine type annotations to perform static type checks with MyPy with detailed doc strings? So it's kind of along those same lines.
Oh, so you already have detailed doc strings and you want to add type annotations. Yeah, that's a good question. I'm not actually familiar with a way to do that. So it's sort of, I guess there are type checkers that check doc strings and there are type checkers that check static typing annotations. I'm not sure if there's any that do both. I'll try and find out and I'll let you know in the chat.
Someone says, what about myPyC? Is there a future for compiled Python using type hints?
I think there might be. I don't know a whole lot about myPyC, but yeah, definitely I can connect you with folks that are working on that and yeah, there's some interesting developments there, I think.
All right. Well, once again, thank you very much.
Thanks.
And,
great to be here.
Okay, so before our next speaker here, we got a word from our sponsor. So hang tight for that, and then our next speaker will be coming up.
Energy is part of our daily lives, but do you understand where it comes from, how it's transported, bought, sold, and the software that powers this? That's where we come in. Join the team developing the energy solutions of the future. Tradeport, where talented people never stop innovating.
All right, so next up, we have one more speaker here. And by the way, stay tuned after our next speaker because we have a keynote from Jessica McKellar on this same track. So stay tuned. That'll be starting in about 45 minutes. So anyway, stay tuned for that. Anyway, so next up, we have a programmer and author who founded his own software company. He mentors young developers, especially through his company's internship program. He's written a number of articles on a variety of computer science topics, ranging from the technical to the interpersonal. He's the author of the forthcoming no-starch book, Dead Simple Python, based on his popular article series of the same name. And he draws rather heavily from his journey of recovering from a traumatic brain injury to help people achieve their full potential. So in addition to his programming career, he's a fiction author, independent songwriter with a love of absurdist humor and wordplay. So if you could please welcome Mr. Jason McDonald. Yes, well, thank you, random bow tie person who looks remarkably like me. So, I'm going to be presenting today on the Zen of Python, which is something that is near and dear to my heart. I've been in the Python language for quite some time. It's something I really love, and the Zen of Python really spoke to me from a pretty early time. So let me see if I can properly screen share this. I've been running everyone else's screen shares, and at this point, I am not sure how to do my own. Did I? Okay, I'm having some technical difficulties here. Hang tight with me. Go figure. I know how to do this. Okay, so I'm just going to scooch this down, and let's try this again. Hopefully, sorry. Hang tight. I will get this. Okay, and here we go. So hopefully that can be seen. There we go. Now we can see my talk. That is awesome. Okay, so so the question is, what does it mean to write Pythonic code? If you've been using the Python language for any length of time, you have probably noticed that there is a canyon of difference between functioning code and Pythonic code. Tim Peters' now famous, or should I say infamous, poem, The Zen of Python, is considered one of the pithiest summaries of what constitutes Pythonic code, but I think sometimes it seems a bit open to interpretation. So in this talk, I'm going to be breaking down how I believe the 20 aphorisms, yes, 20, I swear that's not enough by one error, of the ZennaPython can be applied to your code right now. And even though this is, it says on the guide, this is geared towards beginners, I think this is something that anyone can benefit from. So a little bit about me, like it was mentioned previously, I am the CEO, lead developer of Mousepalm Media, which is my own open source startup. We make educational software, and we are working on building an open source game engine as well. I'm the author of Dead Simple Python, which is soon to be a book from No Starch Press early in 2021, hopefully. And I can be found all over the internet as CodeMouse92. I'm especially visible on Dev and Python's chat room on Freenode IRC. But you can find me all over the net, you know, Stack Overflow, GitHub, Twitter, very active there. You can find the complete list of all the things I do and all the places I am at my website, indeliblebluepen.com. So in case you've never read the ZennaPython, or if it's been a while, I'll just go ahead and read it to you now. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. Flat is better than nested. Sparse is better than dense. Readability counts. Special cases aren't special enough to break the rules, although practicality beats purity. Errors should never pass silently, unless explicitly silenced. In the face of ambiguity, refuse the temptation to guess. There should be one, and preferably only one, obvious way to do it, although that way may not be obvious at first unless you're Dutch. Now is better than never, although never is often better than right now. If the implementation is hard to explain, it's a bad idea. If the implementation is easy to explain, it may be a good idea. Namespaces are one honking great idea. Let's do more of those. So to understand the ZennaPython, we have to start with understanding where this thing even came from to begin with. And this showed up in a June 1999 comp lang Python thread, which was rehashing an 8-year-old debate about garbage collection. And developer Patrick Phelan suggested that Guido van Rossum and Tim Peters should work out some sort of elements of style for Python, to which Tim responded with a notably snarky, humorous attempt at it. It wasn't until 2004, though, that it actually gained the name The Zen of Python and was codified as the PEP20 we know and love. And fun fact, although you may already know this, if you run import this in any Python shell, that'll display the Zen. Funny thing, though, is if you read the source code for that Easter egg, it doesn't even follow any of its own advice intentionally, because we all love irony. But before I can really break down the Zen of Python, we have to answer this question about whether or not Tim Peters was actually being serious when he wrote it. Well, as Tim later described to Barry Warsaw, it was a throwaway Python list post. But like all great triumphs of literature, it was written during commercial breaks while watching professional wrestling on TV and munching on a ham sandwich. All true. That's Tim Peters for you. Ironically, his post initially fell on deaf ears as that garbage collection wrestling match raged on. And like I said, it wasn't until 2004 that it was really codified. But whether this was intended as a joke or not, as Barry Warsaw pointed out, the ZennaPython captured the language's aesthetic through the eyes of one of the earliest Pythonistas. By the way, I should mention that Barry Warsaw also set this thing to music this past May. So you can find that on his website. He recorded a song, the ZennaPython, which I think we should all learn how to sing. Maybe we should sing that at our next conference as our anthem. So I'm going to break down this statement by statement, but instead of going in order, I'm going to address several related concepts together. And I want to start right in the middle, as I believe the entire ZennaPython hangs on this one statement. Readability counts. Pythonic code is readable above all else. Because see, the computer is not picky. It's happiest with binary any day. Programming is really the art of converting human thought to computer logic. Code exists for people, whether they be coworkers, future maintainers, people learning from our code, or just ourselves 2 years from now. And it's really tempting when we're coding to try and write clever code. It feels cool to write clever code. It makes us feel smart. But as you're going to see throughout this talk, clever is kind of the very antithesis to Pythonic. It doesn't mean that we shouldn't be writing brilliant code, but clever code can be a bit of a problem, especially because it often sacrifices readability. Brian Kerrigan, the co-author of the C programming language, don't knock it, Python was written in C, or at least the main interpreter was. He said, everyone knows that debugging is twice as hard as writing a program in the first place. So if you're as clever as you can be when you write it, how will you ever debug it? I would like to add, if you can't debug it, how is your successor supposed to? So later on in the Zen, Tim says there should be one and preferably only one obvious way to do it. This is one of the most quoted parts of the Zen, but what is obvious? Well, obvious is, I believe, all about finding the optimal solution to a specific problem. What is the best possible way to solve this specific thing I'm trying to solve in my code? The trouble with obvious is that it's not always obvious looking into it. It's only obvious looking back, retrospectively. Reading the code, you go, oh, yeah, that makes sense. Why did I think of doing it any other way? That's what obvious means in Python, as you'll see in a moment. Now, our mantra in Python is there's only one way to do it. This contrasts with some languages like Perl, where they say there's more than one way to do it. And we say this in C++ too, which is my other language. But the trouble is, both Python and Perl ships working code, maintainable code. So who's right? I would actually argue that Python and Perl are not really on opposing sides at all, and understanding this will help make this concept of obviousness more easier to understand. Apparently, Guido van Rossum doesn't think that these two languages are on opposing sides either, because he said, when asked about it, the funny thing is that while there's a lot of animosity in the lower ranks, I've actually been very friendly with Larry Wall and Tom Christensen ever since we met 5 years ago at the VHLL symposium that Tom organized. So if Guido's getting along with the creator of Perl, we probably should too. So like I said, these are not on opposing sides, and I'll show that by breaking down kind of these two mantras. So in Python, like I said, we say there's only one way to do it. We are looking for the one obvious way for each unique situation. The trouble is we don't necessarily know this right off, because remember, obvious is retrospective, so we have to try things out. We have to experiment to find the best way to do it. Over in Perl, they say there's more than one way to do it, and this is a way of keeping people from shutting down experimentation because, well, we've always done it this way. But the goal is still looking for the best solution to that particular problem. It's not that we're just looking for any solution, it's that we're still looking for the best one. So you see that this is the same strategy, it's just the opposite focus. Python says find the optimal solution and experiment if necessary. Perl says experiment to find the optimal solution. So really it's the same thing in many ways. But on this whole note of obvious, like I said, that one obvious way is retrospective. Which is why Tim says, although that way may not be obvious at first unless you're Dutch. Once we know the solution, once we see the working code, then it all becomes clear. Now, Python's implementation details do advise this. When you understand how Python does things behind the scenes, it helps you pick better approaches for your particular situation. But we're not all core developers. We don't all know the inner workings of Python necessarily. You know, Guido understands it better than most of us, ergo, unless you're Dutch. So he'll get to the obvious way probably before most of us will. But then there's also this factor that the one obvious way is continually evolving. I have a copy of the Python cookbook from Python 2.4, you know, ancient history. And all the solutions in there, of course, were the obvious way at the time. Python cookbook was very popular at that time. But it's no longer none of these are any longer the one obvious way. The one obvious way has changed as the language has changed. So it's important to remember too that what's obvious yesterday may not continue to be the obvious solution tomorrow. So Python code is readable and it's obvious. It's also beautiful. Beautiful is better than ugly. The trouble is, what is beautiful code? Beauty's in the eye of the beholder. It's a little hard to nail down. But however you define it, beautiful code is always a pleasure to read because we don't want to sacrifice readability. It can be really hard to nail down what beautiful code is sometimes, but you know beautiful code when you see it, and you know ugly code when you see it. Most people would agree, given one piece of code, that yeah, that's pretty bad, or yeah, that's pretty good. And in terms of writing this is why we have the PEP 8 style guide to begin with, to help advise writing beautiful code. Although that's not the whole picture of beautiful code, but it's a good chunk. So this makes the most sense with some actual code. So here's some ugly code. Enough said. I take full responsibility for writing this monstrosity. What are the problems? Poor spacing, for one thing. The lines are crammed together. We have multiple statements in one line and defining N and R on the same line. If just, you know, the conditionals, the header and the suite are on the same line. This is just nasty. It's overcomplicated. Besides that, it's hard to read. I'm not using any of Python's particular abilities. I'm just writing C code in Python, basically. This is not nice. Here's the same goal, but done beautifully. So this employs better spacing, especially around those operators. As you'll see later, white space is important. There's one thought per line, so it's much easier to break down what is going on. It's idiomatic. I'm using Python as Python. I'm using this list comprehension. I'm using the star operator. If you don't know what these are, of course, you may have to read the documentation, but once you know the syntax, then it's very obvious what I'm doing. And this is easy to read besides that. Now, that is not to say that all list comprehensions are automatically beautiful, but I think this is one case where they are. So Pythonic code is readable, it's obvious, it's beautiful. What else? Pythonic code is explicit. Surprising behavior was always a problem. By the way, a little bit of a relevant rabbit trail. This is why I'm well known around the internet for my dislike of JavaScript. It's not because I'm picking on JavaScript or because, you know, just some random personal dislikes of the syntax. My issue with JavaScript is simply that it has too much surprising behavior. And even its experts will admit this. Surprises are bad in any language. Most of our issues with Python even come from surprising behavior. If you've ever tried to pass a list as a default argument to a function, you know what I'm talking about. Mutability can be surprising. So we want to avoid surprising behavior. And besides that, if you have to comment what the code is doing in order for it to be clear, then you really need to be rewriting the code. The code's not Pythonic at that point. Now, that's not to say I don't believe in comments, but comments have a specific purpose. They should be describing the intention. Comment why, not what. I like to use the rule that the comment, should describe the behavior without having any reference to the actual implementation. And in effect, a good comment is part of a living specification. And if the comment doesn't match the code, then you assume both are wrong, and you check and rewrite both to make them match. And then, of course, there's this issue of naming. Because usually when you're reading code, you're looking for a given behavior, and the name is one of the first places you're going to look. Never send a comment to do a name's job. And yes, naming is hard, fully acknowledging Phil Carlton's famous quote, there's only two hard things in computer science, cache invalidation and naming things. So here's an example of some implicit code where this becomes very clear. The names are vague. We're parsing data. What data? What are we parsing out of the data? Who knows? Where is this sep coming from? I don't see it defined. Okay, maybe it's coming from that star import, but if I have more than one import, then that gets a bit foggy. And what is this even doing? I have no idea. We're parsing data out of some file, I guess. Here's the same code, simply rewritten to be explicit. I've changed none of the implementation. So the names now reflect the purpose. I'm parsing a name out of a line. Those lines are coming from a list. I'm putting into a list called speakers. Okay, this is coming from a file. This is making more sense. And I've clarified that sep import. That's coming from constants. So that's useful information. I know where that is defined. It's very obvious what this is doing, and if it weren't already, that comment makes it much clearer what the goal is. So focusing a little bit on that import situation, so explicit is better than implicit, and adding to that, namespaces are one honking great idea. Let's do more of those. See, the thing is that import star, I showed a moment ago, is absolutely insidious. First of all, because Python doesn't have any concept of overloaded functions like you may be familiar with from languages like C++ or Java. Instead, it just shadows the previous function. You can't have two functions named spam. The second one is going to hide the first one. And this can have some pretty unexpected side effects and consequences. And working backwards is really hard when you don't even know what module something is defined in. So an example of namespacing being important is here. So we're start importing from two modules, door and window. Who knows what we're importing? It's unclear what we're even really doing. Am I opening the door or closing the door or the window? And open, by the way, fun fact, that's coming from window. I defined it in door and window in complete defiance of good sense. And it happens. And that, of course, completely shadows the built-in open function, which then means, okay, this is going to be surprising if we now try to open a file later on. Or if I want to edit slam, where do I edit that? What module does that come out of? And if we were to import star this module that you're looking at here, then all of these problems would just replicate up to the next level. So this is bad. Let's fix that. No more star imports. And as a result, we no longer have shadowing. We're using explicit namespaces. Door.open. Okay, so I could use the built-in open function just fine now. It's also clear what I'm doing. I'm opening a door, I'm slamming a door. The intent is much more obvious. And it's clear where this stuff is originating from as well. So if I want to edit slam, I go into door. So on this same point, in the face of ambiguity, refuse the temptation to guess. So when you come up against code that is not overly explicit, you need to insist on knowing what's happening. Abstractions are not there to save us thinking. They're there to save us typing. You still need to understand when a linked list is being used versus versus an array, because that's going to have implications on the performance of your sorting algorithms, or even whether or not you use the built-in sorting algorithm. What algorithm does it use? You know, how does that function you're relying on actually operate behind the scenes? You should have some understanding of this because it's critical to the debugging process and to writing good, solid, maintainable code. Guessing what's going to happen is just going to lead to bugs and misunderstandings. If it's not your code you're dealing with a library, you're dealing with Python itself, which has, unfortunately, some surprises in it, read the documentation. If the documentation is sparse, read the code. Find out what's actually going on. Abstractions are there to save us typing, not to save us thinking. But if it's your ambiguity, if it's your team's ambiguity, just fix it. Explicit is better than implicit. Okay, so Pythonic code is readable, obvious, beautiful, and explicit. Ideally, it's also simple. We write code to be maintainable, not to be clever. And I think you're going to see an example of this here. You got that voice in your head that says, well, a real programmer, don't you hate that term? A real programmer wouldn't use an if statement, and you wind up spending all this time looking up some sort of advanced way of handling what an if statement would have done perfectly well doing. And I guarantee almost every person in this audience has had a moment like that sooner or later. I know I have many times. But you have to understand it takes more skill to write simple, maintainable code than to write clever code. So let the simplicity be your show of skill. It's hard to read clever code. It's hard to understand it, ergo clever. The basics are your friends. So here's some complex code. This isn't necessarily bad, but you see, I've tried to make this dry by taking this input logic and putting it into its own function. But I'm only using it once, so this is dry, nearing absolutely arid. This is terrible. Because now I have to add this extra level of complexity. I have to do this sysexit call, which works, but what if there's some unexpected side effects of sysexit that I'm not thinking about? So this is adding complexity that, while it's okay to ship this, it doesn't need to be there. I can just stick with the classics, the infinite while loop with a break statement. This is easy to read, easy to maintain. Stick this in my main function and I'm good to go. So the simple solutions are sometimes the best. In fact, if you have a simple solution, it's probably better to do that than a complex one. But complex is better than complicated. While simple is best, it isn't always possible to go for simple. And you don't want to confuse elegance with obfuscation. I don't know where I picked this up. It was somewhere on Twitter, but I loved it. Elegance is not obfuscation. Complex code still needs to be readable, beautiful, and obvious. It might take you more time to read it, but it should not take more effort to read it, as long as it's Pythonic. So this is bad code. This is complicated code. Once again, this is kind of like writing C code in Python. Oops, sorry about that. There's too many steps here. First of all, I'm not even going to sport your intelligence by breaking this down. The logic is obfuscated. I'm completely ignoring all the wonderful syntax that Python offers to simplify this. This is just plain nasty. Okay, so what if I wrote code for finding the greatest common factor and I made it just complex but not complicated? What would that look like? Oh, much better. Tighten the logic up. First and foremost, it's very clear what this is doing. You don't have to struggle to understand this. It just takes more time to read it. And I'm utilizing the syntactic sugar. I've got a set comprehension. I've got a conditional in this comprehension. So this is much cleaner and it works just as well. So, and again, you can get set comprehensions, list comprehensions that get away from you. Do be careful of them, but this is a good case of a nice, clean set comprehension in action. This is good complex code. There's no simpler way to do this that I know of. So Pythonic code is simple or it's complex and it is obvious. So with those in mind, if the implementation is hard to explain, it's a bad idea. That is, if you are having a hard time explaining the code, it's not obvious and it's not simple. It's probably not even complex. At that point, it's getting towards complicated. The problem with cleverness is basically that it's exclusionary. That's the poison. Because it feels clever because you're part of a select set that can understand this. You have the prowess to understand what is going on here, and that is just, that's just terrible. So, cleverness is exclusionary. Don't be clever. You wind up excluding yourself sooner or later because in 6 months, you're not going to remember what that clever code did. But there's an important corollary here. If the implementation is easy to explain, it may be a good idea. Because while all Pythonic code is easy to explain, not all easy to explain code is actually good or Pythonic. And just as all Pythonic code is obvious, but not all obvious code is Pythonic. This is kind of along the same lines as all snakes are reptiles, but not all reptiles are snakes. So your code should be easy to explain, but it needs to fulfill the other criteria as well. So are you still with me? Pythonic code is readable, beautiful, obvious, explicit, and simple, or at least complex. To that aim, Pythonic code is flat. Why is that? Because it's hard to read deep nesting, especially in production code. We can't read white space. And when it gets deep and complex, it's really easy to make mistakes and get it wrong. Is this in the outer else or the inner if? By the way, this only applies to code, not to your data, not to your folder structures and your collections. This is for code. This is overly nested code here. I don't need to say much about this here, but this is really prone to indentation errors. It's hard to reason about what's going on in a multi-nested for loop. And the line limits are now getting painful. True sad story, I worked with a Python developer who switched to 120 line limits and 2-space indentation because he was nesting all the time. If you need to do that, you're nesting too much. So just keep it flat. Instead of this multiple nesting thing, I'm using IterTools product. IterTools is a great built-in library. Please use it. It's very helpful. This is much easier to reason about. Just a quick glance at the documentation, and the line limits are not a problem. We have one level of indentation. Very unlikely to mess that up. Meanwhile, sparse is better than dense. A skilled musician or a composer will tell you that the single most important symbol in music is the rest. As Beethoven says, the music is not in the notes, but in the silence between. Because silence defines rhythm, it defines dynamics, and one note for the next. Without it, music is just a cacophony. The same is true of code. White space gives us a chance to pause and consider what we've read. It allows us to organize the code logically, and again, while one-liners make us feel clever, don't be clever. It sacrifices readability. Do I even need to say anything? This is obviously pretty dense. This is hard to read, even though it's decent Pythonic code. The white spacing is just terrible. So let's fix that. Same code. I haven't changed a single character in this code except the white space. This is much easier to parse. It's broken down into logical chunks. And you know, it's okay that it's a bit longer. Vertical space is there to use. Side note, if anyone's thinking, that's not Pythonic, you could have just reversed the spring. Hey, I optimized for time and space complexity on this one. So this is Pythonic for my goal. It's for checking for a palindrome. I'm gonna get through this here as quickly as I can then. I don't have any questions yet. If anyone does have any questions, put it in there. If I don't get any of those, I'll probably go towards I'll probably use a little more of my time. So the term exception is meaningful. Errors should never pass silently. An error is an exceptional state. It means we've left the happy path, and we're now into a territory where we need intelligent intervention to resolve it correctly. So if there is no intelligent intervention, it's best to just crash the program at that point. An error caught at its origin is always going to be easier to debug than errors created when an exceptional state moves forward blindly. And I like how Python developer Mike Pernot calls this the diaper anti-pattern whenever you have this catch-all, because you're catching all of the errors and you're silencing them all. The exact opposite at this point of the Zen. Mike says, in the harsh and unforgiving real world, the source may be tens, hundreds, or even thousands of lines away, buried under umpteen layers of abstractions in a different module, or worse, in some third-party library. And when it fails, just as diapers fail, it'll fail in the small hours of the night when we would rather be sleeping, and someone important will make an awful fuss about it. It will not be fun. So all that to say, you know, don't silence errors. Just, you know, don't let them pass silently. Let them explode where they're happening, unless explicitly silenced. It's okay to explicitly silence an error, but only if you've already applied intelligent intervention or you've otherwise resolved the exceptional state. So if you already know, okay, I don't have to worry about key errors here because I'm just going to return none, that's fine. Silence that error and move on. But if there's an unexpected error there, perhaps you get a runtime error, which if you're getting that on a dictionary read, you got bigger problems than errors. But you need to be specific. Silence only the error you resolved and let everything else continue to blow up at the source. Just because it works on your machine and you pass the test does not mean that it's actually going to be safe and sane. So be very aware of that. Explicit is better than implicit. Okay, so these next two aphorisms really aren't so much about Pythonic code as about Pythonic coding. And the biggest lie we tell ourselves, I think, is I will do it later. So Tim says, no, now is better than never. Because when you say I'll do it later, you probably won't. And the longer you wait, the more you're going to have to refactor your code to pull it off. So the important thing is to do whatever you're thinking about while you're thinking about it. While the idea is fresh in your mind, just implement it. Or at least set yourself up to be able to easily implement it later. A really good example of this is at my software company. We are building a game, and we have some features we want to add in a later version. We don't want to add them right now. We're trying to limit our feature set for 1.0. So we simply left spaces for us in the code, and we structured certain parts of the code to allow us to do these things down the road. We aren't doing them right now, but we have the space to do them. But important and perhaps confusing corollary, although never is often better than right now. Isn't this a contradiction to now is better than never? No, because of the other lie we tell ourselves. It'll only take a minute. Yeah, right. If you have to drop everything to add a bell, a whistle, or a gong, it's just not worth adding at all. So this is all about priorities. You need to ask yourself, is it really needed, or are we just piling on needless features? I can't remember who coined this phrase, but someone said that that all software will naturally evolve until it is capable of sending email. Want to be very careful not to let unnecessary features creep in and push out more important things. Special cases aren't special enough to break the rules, Tim says about this whole Zen. But my code is different, you say. Okay, great, but that's not actually an excuse, because new code is really the only code worth writing. It may be a similar goal, but your code is new, hopefully. Your approach is new. So if novelty were an excuse, there would be no point in having a standard at all. But we need a standard in order to make things sane. Corollary, although practicality beats purity. Because you have to remember, the aim of the Zen, or any good standard, is to protect and enforce readability, maintainability, stability, and performance. And if the rules are detracting from these goals, we may be justified in breaking the rules. So you can break the rules, but you have to have an objective reason to do so, and that reason can only come from the end. You know, do you need to break a rule in order to keep this code stable, perhaps, or maintainable? Okay, then go ahead and break the rule. But if the only reason you're breaking the rule, you have to think carefully about this. The reason you're breaking the rule is because of how you chose to implement your code. What needs to change is not the rule, but your implementation. So make sure you are only getting your exceptions from the end and not the means. Okay, so on the label, I said 20 aphorisms, but the Zen only has 19. But like I said, don't worry, this is not an off by one error, because as Tim said in his original post, 20, counting the one I'm leaving for Guido to fill in. He left a spot for the benevolent dictator for life to add something, but Guido never did. And perhaps this is just as well, because Python really isn't the work of just one person. It's the work of the entire community. It's always changing and growing and evolving. Just imagine what EuroPython 2030 is going to look like. It's going to be phenomenal. There's going to be ideas here that are just completely new to us. And it's going to make all the trendy and new and fresh stuff from this conference feel really dusty and outdated. The Zen of Python fits neatly inside the principle of Pythonic code, but you really can't contain Pythonic into any one document. There's a certain flavor to it that the Zen somewhat approximates, but can't fully encapsulate. Pythonic is just something you learn from experience. It's always being debated, parsed, rehashed, reworked, challenged, improved, but interestingly, since 1999, the Zen has remained completely unchanged. Pythonic code is always readable, obvious, beautiful, explicit, and simple or complex. We just find different ways of doing these things and better ways of doing these things. So I really hope by explaining the Zen of Python to you, I've given you some practical insights in how you can improve your code using this rather infamously snarky little poem. So yeah, thank you very much. So I do have one question here, and if anyone else wants to chat with me after this, I'll be in the Talk Writing Zen Like Python channel over on Discord, and I'll be happy to chat with you all there. So I have one question from Martin. He says, what's your opinion on code formatters like Black that made code universally readable, but in some cases ugly? I would say, well, like with most things, it just depends on what you're doing. Personally, I like Black. That's my own take on it. I rather like it because it generally makes my code more readable and not less. But if you are consistently discovering that your code is not being improved by Black, then this is why we have other tools. This is why we have, you know, PyFlakes or not PyFlakes. Well, we have Pep8 and we have various other tools that can, their names are escaping me right now, that you can customize to meet your needs more specifically. So, you know, if Black doesn't work for you, just find something else, or, you know, you can go the old fashioned route and just memorize Pep8. Actually not hard to get used to once you've been working with it for a little while, and then you can just apply it yourself and not worry about your auto formatter and its opinions on things. So, yeah, I'm actually finishing a little bit early here, which is okay. That's awesome. So stay tuned, because coming up next, we have our keynote speaker, Jessica McKellar. And I'm actually going to turn things over at this point to the next session manager. So it's been awesome seeing y'all here, and I will answer any other questions y'all have over in Discord.
Hey, so I guess we have 2 minutes to fill in before we start officially.
I can add a word from our sponsors at this point if you would like me to.
Oh, yeah, we can do that.
Oh, no, I take it back. I'm not ready for that. Yikes.
Okay. I just couldn't start sentence or not.
Actually, I can do it. So here is a brief word from our sponsors while we get everything ready to go.
Okay, that's awesome.
Salut! Eu sunt Eric și fac parte din echipa care asigură taxonomia comodităților aici la Bloomberg. În fiecare săptămână dedicăm jumătate de zi pentru a lucra la proiecte personale. În acest timp am realizat o librărie care se ocupă de validarea claselor de date ATDRs.
It's nice that we had an ad that was not in English.
Indeed, I like the variety.
I think we can start now. Or should I wait a minute for people to come in?
I would just wait till the time slot, 2 minutes, I think.
Okay. Oh, yes. All right. I think I'm going to start now. Hello, everyone. Welcome to the last keynote event of the day. So, the United States has the highest incarceration rate in the world, with over 2.2 million people behind bars in our prisons, jails, juvenile facilities, and detention centers. What do we do as software engineers? To elaborate, we are joined by the amazing Jessica McKellar. So over to you.
Thank you so much. Let me make sure I can get my screen sharing set up reasonably. 1 second here. And then if I go ahead and can I get some affirmation on what, if any, slides you see?
Yeah, we see your slides.
Great, okay. Welcome everyone. My name is Jessica McKellar, and we're here today to talk about Python in prisons, how open source can change a criminal justice system. The United States locks up more people per capita than any other country. I live in San Francisco in the state of California in the United States, and this is the country that I live in. I live in a country that still has the death penalty and routinely executes people at the federal level and in many states. I also live in a country where children serve life sentences without the possibility of parole. In other words, children are condemned to die in prison. My state, California, has the largest death row in the Western Hemisphere at San Quentin State Prison, which is just 45 minutes away from where I live in San Francisco. I live in a country where the criminal justice system is a direct successor to the control and labor economics of slavery. In some counties, prisons are the single largest employer. Prisoners literally build and run the prisons that confine them. Building, construction, and maintenance, meal preparation, laundry, janitorial services. Every California license plate is made by an incarcerated worker at Folsom State Prison. Incarcerated workers are paid 8 cents to 37 cents per hour for their work. By comparison, California's minimum wage is currently $12 per hour. 1/3 of California's firefighters are incarcerated firefighters. California actually doesn't have enough firefighters to fight its fires right now because the prisons are on lockdown due to COVID-19. And so those incarcerated firefighters are not available, and they've become part of the system. We rely on them. The system is extremely racist, and it's also ineffective. Our prisons don't prevent crime. They actually increase it because incarceration produces a lifelong record and stigma that makes successful reentry with stable housing and employment extremely difficult. The system is ineffective, and it's not even what survivors of crime want. This system persists not because it is a good one, but because it is an effective system of racial control and because it generates a lot of money. I talk about prison a lot because some of the most important people in my life are or used to be in prison. Friends, coworkers. I spend time every day with people who used to be in prison, people who were serving life sentences for serious violent crimes, but who, despite the brutal circumstances of a prison system that is not sincerely interested in their rehabilitation, did the work to understand their own trauma and the harm they caused and became different people. I talk about prison because this brutal, ineffective, unjust system must be dismantled. And I talk about prison in forums like this one because it's a system that people like us, tech people, open source people, are actually disproportionately able to change. And that's what I'm here to talk about today. So as a quick reminder on who I am, my name is Jessica McKellar. I'm sort of a lifelong Python user and participant in the Python community. I helped build the Boston Python user group into the largest Python user group in the world. I was a director for the Python Software Foundation. I've been the diversity chair for PyCon North America for half a decade. My particular passions within the Python community are expanding access to programming and teaching new programmers. I also spend a lot of time in prison and supporting reentry for people getting out of prison. I actually teach a Python programming class in San Quentin State Prison in California. Every company that I've ever worked for has had a Python tech stack. I'm currently a founder and the CTO of a tech company in San Francisco called Pilot that of course uses Python, and a bunch of Pilot's employees are formerly incarcerated. One of the engineers at my company is named Simon. Simon was incarcerated as a child and grew up in the California prison system. He learned how to speak English in prison. Simon also learned how to program in prison through a nonprofit called The Last Mile, which is how I met him. The Last Mile was created to teach incarcerated people technology skills that align with modern labor markets, so that when graduates get out of prison, they can successfully get a job. Prior to The Last Mile, most of the work experience available in prisons was manual labor. You could learn how to cook in the prison kitchen, you could get certified as a janitor while working on the prison custodial staff, or perhaps you could learn something like carpentry through the Prison Industry Authority. And these are all important jobs and skills, but in practice, it can be difficult to secure a job in these areas of the labor market when you get out of prison. So The Last Mile took a new approach and decided to focus on one of the fastest growing labor markets in the United States and to teach people how to program. The Last Mile's coding program was started in 2014 and is the first ever computer programming curriculum in a United States prison. In this program, students learn HTML, they learn JavaScript, they learn CSS, and of course they learn Python. There is no internet access in these programs, so everything is done through thumb drives and PDFs. And this was Simon's introduction to programming. After he got out of prison, he went through a coding boot camp called Hack Reactor, and then interviewed for and accepted a full-time software engineering role with my company. But very few people have access to a program like The Last Mile. It's only running for a few dozen people in 11 prisons in the United States. And we have a lot more than 11 prisons, unfortunately. And that's a problem, because for most incarcerated people, becoming a programmer changes your life. It gives you access to the economics of being a programmer, the cash, the startup equity. More importantly, it connects you with other programmers. You become part of a group of people who have resources, who have power, and who are used to living in a world that we know we can change because we do it every day at work. Programmers fix stuff for a living. We are great at fixing broken systems. And I think it's worth dwelling on where that sense of empowerment and agency comes from. It is deeply ingrained in our open source culture in particular that we have the power to take things apart and change them and fix them and make them better and share those improvements with the world. That is an incredibly powerful mindset. And we mostly apply it to software systems. It's how Python exists. Guido saw a need for a new kind of language that was open source and intuitive and easy to learn and powerful. And he and many other people worked together to make it so. It's why we have this rich ecosystem of Python libraries and why we have this incredible international Python community. It's why we have not just Python 2, but also Python 3. We believe that we can change things and make them better. So where I start getting really excited is when we take these tremendous capabilities, the collective resources and power and the confidence that we can change things, and direct that not just towards software systems, but also to people systems. Because a programmer's mind is really an activist mind. We can't even help it. This is a video of Simon getting his ankle monitor removed. So for many months after he was released from prison, Simon was required to wear an ankle monitor at all times to track his location. While on parole after serving nearly 2 decades in prison, newly hired into his first software job, despite being under 24-hour surveillance by the state, Simon wasted no time leveraging his network, his new network of software engineers, to help change a system that has brutalized him and so many other people. The first thing Simon did was bring more talented, formerly incarcerated people to Pilot, changing the economic circumstances for several families. He led the creation of a mutual aid network, the Bay Area Freedom Collective, that has raised over $50,000 to provide re-entry support, housing, and employment to people getting out of prison. As a company inspired by Simon, we have organized around campaigns to change legislation in our state around incarceration. We have led campaigns to free vulnerable people from prison during the COVID-19 epidemics, and we have succeeded. We now run coding workshops to help last mile graduates prepare for software engineering interviews, and we're helping formerly incarcerated entrepreneurs start their own businesses. And this is just the beginning. And it's not just Simon. This is my friend Emil, who now works at Pilot 2 and is a prison abolitionist and community organizer. This is my friend Shah, who now runs a media company centering the perspective of formerly incarcerated people in discussions of current events through videos and podcasts. There are so many talented people in our prisons. If they had the resources to change the world, they would. And we can help make that happen. So that brings us back to how we tech people can meaningfully change a criminal justice system. So inspired by Simon, as an exercise, let's talk concretely about what each of us can do to change a system like this. And the system in your country might look really different from mine, but I think it's still an interesting and useful exercise to practice thinking concretely about how we can engage with a big, broken people system that must change. So when we get a large, ambiguous engineering project, the first thing we do is a little planning and decomposition, a breakdown of what problems we're trying to solve and approaches to solving them. So first things first, what is a non-overwhelming way of thinking about criminal justice, mass incarceration? What's a non-overwhelming way of thinking about these topics? And then some practical goals we could have together and as individuals within it. And here's a framing that I have found helpful for myself, breaking it down between opportunities for systemic impact and individual impact. For systemic impact, my goal is decarceration, changes to how we as a society think about crime and punishment that lead to legislative changes that lead to decarceration, fewer people incarcerated for less time. For individual impact, by the data, two things that matter the most are housing and employment. A safe, supportive, stable place to live, and a stable job that ensures that you'll have the money to take care of yourself and your family. Technologists should be great allies in the pursuit of these goals. We have access to great jobs. Tech as a sector is perpetually hiring, which is not true everywhere else. We have skills that are useful. We are tech savvy. We have technical skills we can teach other people. We know how to make things go viral on the internet. And third, we have money. Generally speaking, this is a financially privileged group. And so as technologists, I'd frame up three categories of opportunities we have to affect systemic and individual impact. As individuals, as any old human being who cares about this topic, as technologists specifically, and then also in partnership with our employers. So as individuals, there are a bunch of things that we can do. First and foremost, we can directly support people leaving prison. At least in California, at least in my country, many people who get out of prison don't have any of the basic things that we use to get by in society today. You don't have a cell phone, you don't have a computer. This may sound remarkable, but it is literally true. In California, it doesn't matter if you have been locked up for 40 years. The way that this works is when you get out, you're given $200 and a ride to a bus stop. And that's the support that you get to make it on your own. So direct support for people leaving prison is a really, really important way that we can show up. Once people get out, bridging this huge gap left by the government, local reentry programs do the hard and important work of helping people with housing, with job searches, staying sober, staying safe, and a lot of other things. And most of this work is done by volunteers. A lot of the work doesn't require a special background. This is work like helping people write resumes, learn how to use a cell phone, learn how to use a computer. We could all be one of these volunteers. And then finally, as individuals, we can't forget the reality that our criminal justice system is unfortunately a highly politicized system. And one of the ways to change it is through who we elect as our representatives and public officials. So it's really important that we vote, especially for positions that can impact the way that our prison systems are run and who gets sentenced and how. So that's the story as individuals. On top of what we can do as individuals, we have ways that we can uniquely contribute as technologists. And the first, which we've sort of already alluded to, is the first is tech-focused job training and reentry inside and outside of prisons. Inside of prisons in the United States, we can volunteer with programs like the Last Mile. And maybe you have something similar in your country, or maybe there's an opportunity to make something like this grow or come into existence. But you know, pre-release job readiness skills, really, really important. And then outside of prisons, you know, a lot of re-entry programming is about tech literacy. It's about how to use a cell phone, how to use the internet, how to write an email well. You know, how are you supposed to get a career-building job if you don't know how to type? Or if you don't know how to use a computer to complete an online application with confidence? So having enough support for these types of skill development is really, really important. And then I want to specifically call out another area of opportunity that is of exceptional relevance to this group of people, and that is programming boot camps. And this really intersects with a lot of the work on diversity and inclusion that this community is already doing. Boot camps, and more generally, software engineering training for people who want to make a career transition, they're proving to be an important re-entry opportunity for people coming out of prison. Regardless, potentially, of the prior career that you had prior to incarceration and the skills that you managed to develop in prison, if you can get into a programming boot camp, that can really change your life. So it's important that we're thoughtful about what opportunities folks have to engage with these types of programs. And then finally, reentry and reform work is mostly done by small local nonprofits. And these groups desperately need tech support. Building and maintaining a website, migrating to modern cloud-based collaboration tools, yeah, they need our help. So that was as technologists. And
Hey everyone, we are facing some technical difficulties right now. We'll be back.
are we back? Someone tell me what happened.
Oh, you just froze.
I froze. Excellent. Okay, where did I freeze? Do you remember what slide or what I was talking about?
You froze on the as technologies slide, I think it was.
Okay, so let's see what we can do here. So I'm getting so many notifications from various conference organizers. Okay, one second. Let's okay, what we're gonna do is I'm gonna share my screen. We're gonna get back into this deck. Maybe we will start here, and my apologies if this is slightly duplicative, but make sure we are picking up reasonably where we left off. I'm gonna go ahead and press play. Can you see my screen?
Yeah.
Okay, you can see me, you can hear me. All right, we'll take it from here. Okay, so as a recap, we were just talking about what we can do as individuals to support people getting out of prison. Let's talk about what we can do as technologists. So on top of what we can do as individuals, we have ways that we can uniquely contribute to this cause as technologists. The first is around tech-focused job training and reentry. We had already talked about the last mile. In the United States, we have an opportunity to volunteer with, to invest in, to create new versions of, or to expand programs like the last mile. And I am confident that there are interesting opportunities in this space in every country that has a large prison system as well. So one opportunity is to do sort of reentry support, tech-focused reentry support inside of prisons. And then, as I mentioned earlier, a lot of reentry programming is about tech literacy. This is things like how to use a cell phone, how to use the internet, how to write emails. You know, how are you supposed to get a career-building job if you don't know how to type, or you don't know how to use a computer to complete an online application with confidence? And then I wanted to specifically call out programming boot camps as a huge area of opportunity and intersection with work on diversity and inclusion that this community has already been doing. You know, boot camps and more generally software engineering training for people who want to make a career transition are an important reentry opportunity for people coming out of prison. And you know, maybe you were able to go through a program like the Last Mile while you're in prison, maybe you weren't. Regardless, boot camps are a way to reset the entry point to becoming a technologist, and that's really valuable and can really change people's lives. And finally, reentry and reform work is mostly done by small local nonprofits, and these groups desperately need tech support. Building and maintaining a website, migrating to modern cloud-based collaboration tools, etc. They very much need our help. You know, we should help them so that they can spend all of their time focusing on getting the actual message and the change out, and not, you know, debugging whatever, you know, website configuration issue they're having. So this is another way that we can really show up for these groups. Okay, and then finally, we have the third bucket, and honestly the most important bucket, and that is what can we do as employers? And I say that this is the most important thing because this is where the greatest economic impact lives. That's my belief, at least. And that's a really simple thing. It's just that we need to hire people with records. The number one thing that we can do is we need to hire people with records. And I want to highlight a couple of specific table stakes issues on this topic. And, you know, the details of this may change from country to country, but I suspect that a lot of this is relatively universally true. The first thing we need to do is examine how our companies use background checks. Do our companies conduct background checks? And if they do, what do they do with the results? Do we automatically disqualify people who have felony convictions? If we don't know the answers to these questions, we should find out and organize to make sure that our companies aren't blanket disqualifying talented candidates because of harmful stereotypes. The second thing that's really important is that people coming out of prison may have an educational and career background different from the candidate pools we typically focus on. If we are blanket disqualifying people based on having a particular type of degree, attending a specific college, experience with specific prior employers, we are throwing out resumes from qualified candidates, including candidates coming out of prison. We need to take a hard look at what the true requirements are for our entry-level roles. Does every entry-level person on a customer support team or a sales team or your office management team actually need you know, a 4.0 grade point average from a top-tier university plus a Facebook internship? You know, probably not. You know, they need to be reliable, sharp problem solvers with good communication skills. And we, in turn, need to have good training and mentorship programs to support entry-level employees in their on-the-job skill development. So we need to take a real critical look at if our entry-level roles are truly entry-level and if they're really serving to build a diverse and inclusive workplace. And finally, if we want to hire people with records, we need to spend time with people with records who are looking for jobs. And this is the point that ties together all of the other activities we've talked about. Making a difference usually requires building relationships. In the United States, what I recommend doing is volunteering with job training and reentry programs inside or outside of prisons. That's an easy way to meet and build relationships with people who have the skills and aptitude for the roles you're hiring for. If you do an internet search for reentry programs in your city or in a nearby prison, you will find everything from academic classes to interview practice to resume building workshops to tech literacy training. All of these programs are trying to get people out and into good jobs, and all of these programs need volunteers like us. And when you start hiring people with records, you start hiring people like Simon. And you start taking the system personally, and you become intolerant of the injustice, and you start organizing, and you start acting, and before you know it, you can't help but change the world. Now, maybe prisons aren't your thing, and that's fine, but we've all got something in our country, in our community, a big people system that is unjust and must change. And I hope this talk was a reminder that we have the power and we have the resources to change it. If you'd like to learn more about prisons in the United States, I recommend listening to currently and formerly incarcerated community members. Here are some of the people leading the conversation on prisons in the US. There are some really talented community organizers on Twitter. And then I've linked to the Patreon pages for Shaw, who I had referenced earlier in this talk, and then also for the Bay Area Freedom Collective, Simon's organization. And I would love if you would check those out. And with that, that is Python in Prison, how open source can change a criminal justice system. Thank you for listening. And I look forward to hearing about what big people system you are tackling in the year ahead. Thank you so much.
All right, that was a very powerful talk. So do you want to answer some questions now?
Yeah, absolutely. Let's do it.
All right. So here's the first one. Are there any considerations regarding the box many companies include on their application regarding felony convictions? Is a reassuring note that's sent along with it helpful?
So I want to make sure I understood that. Can you, sorry, can you repeat the question?
Okay. Are there any considerations regarding the box that many companies include on their application regarding felony convictions? Is a reassuring note along with it helpful?
Perfect. Yeah. So at least in the United States, and again, this is, I'm sure, various country to country. In the United States, depending on what state you're in, employers or potential employers can ask you about your criminal history and can use that information to discriminate against you before they've really interviewed you. And in some states, that's actually been made illegal because it has such negative consequences for people who have records but have served their time and are back out in society and still need to be able to get a job and pay the bills and take care of themselves like anybody else. So some states like New York, for example, have passed legislation to ban the box, where you can't ask about if people have a felony conviction prior to making them an offer. So that's a really important, that it's a small piece of the bigger story, but it's important that we are giving talented candidates a real shot during job interviews without prejudging them based on something from their past. So that's really important. More states should adopt that legislation. In general, there are significant barriers to employment. It's not just that, but the broader topic of how to, if you don't want people to go back to prison, they need to be able to get a good job, right? So like what if we had to envision from the ground up what kind of system would facilitate that? And that's a win-win-win. That's about reducing crime rates and improving, sort of building successful communities. If we could start from the ground up and invent a system that really ensured that everybody was able to get a good job that could pay the bills, what would that system look like? Because it definitely wouldn't look like our current system. I see a question in the Q&A box. Should I
Yeah. So here's the next question. Have there been studies done comparing recidivism rates among those that have been through programs such as the last mile and those who are without such programs? If so, do people and politicians listen to that data?
Yeah, it's a great question, and there's a bunch to unpack in this. So first, recidivism rates are that's a specific quantification of people who get out of prison and then return to prison for some reason. And there's a whole separate conversation about how to do that in a way that is useful, because what timeline we're talking about matters. What was the nature of the activity that caused a return to prison? Was it similar or different from the original offense? There's a bunch of stuff that we could break down on recidivism, but the long and short of it is that in the United States, recidivism rates are very high. In general, for the total sort of prison population, a lot of people return to prison. That's not because they're bad people or because there's something sort of inherently criminal about them. It's because the system is set up to cause people to return to prison. In particular, the most common reason why somebody who's in prison might get out and return to prison is because the underlying issue that drove their original criminal behavior was a drug problem. And let me tell you, a prison is not a good place to address addiction. It's a terrible place to address addiction. And so it's no wonder that if you were an addict going into a prison, that in many cases, it's very difficult to get the support you need for that to really materially change by the time you get out. So, we could imagine a totally different way of handling addiction in our country that does not involve shoving people into a prison system that's not going to take good care of them, right? So that's like one example of a sort of obvious reason why recidivism rates for one particular population are high. It's because the way that we handle this is stupid. Now, the question was originally about, do folks who go through the last mile, do they have better outcomes? And the answer is definitely yes, because it's all about being able to get a job. Like if you can get a good job after you get out, you're not going to, like there's no, the underlying circumstances that might cause like a need to try to take care of yourself in some way that could cause you to end up back in prison, they just go away if you have a good job. So folks who are, and it's not just the last mile, but if you have like job skills that you can actually get hired for, if you were able to get a college degree while you're in prison, all of these things are like highly correlated with successful outcomes. So educational and employment opportunities are a big piece of reducing recidivism. But the other thing that's important to highlight, though, is that a lot of folks, if we just did a reasonable job of taking care of people, you got to remember this is the United States. Like we don't have universal health care. We have like a very weak social safety net. So this is true of anybody, not just people coming out of prison. Like if you fall on hard times, if you can't get a job, you're in a really tough spot. And so if we, this is part of why I care so much about talking about prisons is it's a lens for talking about broader social change. It's a problem that people aren't guaranteed shelter and food and healthcare in this country. And one way that we see this manifest is in poor outcomes for people coming out of prison. But so yes, the last mile helps, education helps. It's also the case that though, criminality is something that is basically a thing that young people do. People age out of criminality. Like the fact that we have people, spending their entire lives or many decades in prison in the United States is purely the result of sentencing policies that were set not by criminology experts, they were set by politicians looking to be tough on crime so that they would get elected. Like the whole system, the system was not designed to be effective. This is not an optimized system. It's one that is simply excessively punitive and is not effective. So there's a whole, we could talk about prison for days. But to answer the specific question, yes, people who go through the last mile, they get out, they get good jobs, and they don't come back to prison. And a bunch of them are my friends. They're great human beings. Okay, another question. Do I work in women's prisons as well? I do. So actually, the last mile is in several women's prisons. Fun story, a wonderful, talented woman named Linda who went through the last mile I have gone through some interview prep with her, and she's actually going to start interviewing for software engineering jobs in the Bay Area starting next week. She's like ready to go. I'm confident that she's going to pass these interviews. She's super sharp. She's a great programmer. This is a great example of someone who, she was in a different career prior to her incarceration. She's, I think she's in her 40s now. So this is in many ways like a classic example of someone who is making a career pivot to software, after doing something else for the earlier parts of her life. And she's going to be great. She's going to be great. I just got word about some interview prep for her, and I'm really excited about that. So yes, the last mile is in some women's prisons. Again, this is a very small program though. The vast majority of people, 2.3 million people in the United States are incarcerated. The couple of dozens of people who get to benefit from the last mile are very fortunate individuals. But to me, that's a testament to, it works. So how do we expand it? How do we get more people access to more opportunities like this that set them up for real success when they get out? Great.
Oh yeah. So
I appreciate the canned applause.
Yeah. So I think we are almost out of time. So we can take the questions to the breakout room actually, where you can
Perfect.
you can take more questions over there. And thank you for your talk. It was really powerful and really awesome.
I appreciate it. Thank you all for listening. Thank you for dealing with the technical issues with me. And yeah, let's go over to the breakout room. Looking forward to talking with you all. Cool.
Okay. So I have a bunch of announcements to make. So we had Siddha Ganju, who was our first keynote speaker, who was supposed to do the keynote today. So she will be doing her keynote tomorrow. It's scheduled at dinner time. It's just after Guido's Q&A. So that's something which is a development. And also, if anyone wants to play, the party game, you can go ahead and play. It's happening right after this. So you can join Jason and Lice and start playing word pedal. It's going to be awesome. All right.
Az én nevem Gábor Bernát, és Bloomberg adatgyűjtő rendszerén dolgozom Londonban. Ugyanakkor a virtuális és Stokes Python projektek karbantartója is.
Hang tight, everyone. We will be getting started in a moment. I am just waiting for Lais,
I'm
who's
here.
the
I'm
other
here.
half of this brilliant fun time. Hello, Lais.
Hello, hello, hello.
All right, so if everyone's ready for some Python flavored madness, we've got a doozy planned. Should I cue up the lovely music here, Lais? Before they get started on their
Please
Beethoven?
do. Please do.
All right, let's see if I can get it working. There we go. So this is Word Peril. It is the only Python word game in existence that everybody knows of. And
I think we should turn the volume down just a little
yeah,
bit.
like that. Like that. So, if anyone wants to play this absolutely ridiculous and fun game, please raise your hand now over in attendees. And we're going to be getting started here.
Ooh, we have one person that would like to play. Come on, there's so many of you.
Absolutely,
We want to have
yes.
some
And I
fun.
do promise that that's the only time I'll play the song because everyone's going to go listen to Brahms at the same time while watching our game show. So this will be fun. That's going on in Brian right now.
Then I want another person to come and try. Come on, just one more. Dun, 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 dun.
There we go.
Yes, perfect. So we're all going to be promoted to panelists. So Martin and Simon and Vinayak. Here we go.
All right, you guys are y'all are welcome to turn on your screen shares or not your screen shares, but you're welcome to turn on your cameras, and your microphones so we can see and hear you. All right.
And I've played this before, so I'm sorry you have to make. Oh, but you changed the rules, so maybe it's different today.
Well,
Okay, let me. I have you running in the background on the television. I will just mute that, and be back.
Okay, all right, sounds good. And Simon, we just see a black screen. You are in darkness.
That is because I have the physical cover of my camera.
Up there we go. That would do it. Yeah.
So you're in fact seeing a live stream video of the back of the video camera lens cover.
That is fantastic. Absolutely.
What is word peril? And is it written in Python?
Actually, I wrote this specifically for the EuroPython online conference. Although, nerd note, if anybody wants this source code, you can go to github.com/codemouse92/wordperil. I'll put the link in the party room later.
Yes.
And you can get this source code. But don't go looking there for the puzzles because the puzzles are not in that repository.
Nice. Cunning.
Yeah. Okay, so here's how this works basically. I'm going to actually I'm going to start by loading this and then I'll explain the rules here. So let's get everyone into the game as soon as I can type. Awesome. Okay, so we have Martin, we have Simon, and we have Vinayak. Is that the way to pronounce your name, Vinayak?
Yeah, that's correct, Vinayak.
Excellent. I got it right. I love it when I get it right. All right, so basically here's how this works. You're going to see a word puzzle on the screen. You can guess letters. Vowels are worth nothing. Consonants are worth 50 points each as it appears in the puzzle. So you guess a letter, and then if it's in the puzzle, you'll see all the letters, all the instances of that letter in the puzzle. But if you get it wrong, you will lose 50 points. Over here on the side, is used letterboard, show you all the letters that have already been guessed. Vowels are at the top, consonants are below it in an alphabetical order. So basically you get to keep guessing letters until you get one wrong, and then it is the next person's turn. At any time during your turn, you can ask to solve the puzzle. If you solve the puzzle correctly, and you would have to read out the entire puzzle, don't add anything, don't remove anything. If you manage to solve the puzzle, that's 300 points. If you get it wrong, you lose 200. Ergo, word peril. And the person with the highest positive score gets bragging rights and gets to hang out for the next round.
What happens if you guess a vowel incorrectly? Is that also minus 50, or is that minus zero?
That is also minus 50, yes.
So vowels are extra dangerous because you can score nothing but lose 50.
Exactly. So vowels are all risk, no reward, except you might get closer to the answer. So, is everyone ready?
No, but let's start anyway.
Okay. Also, just a heads up, you have approximately 5 seconds to guess a letter. If you hear this sound, then that means that you have run out of time to answer, and play will go to the next person.
Is the order Martin, Simon, Vinyag?
Yes, and then the person to the right of the highest score on the next round gets to go first in that round. So let's see if we can do this.
The round is 10 minutes. That's
yes.
Yes.
Yep.
Perfect.
And,
so we're starting
you've
now.
got that. All right. So I'm going to start this first puzzle. And Martin, could I get a letter, please?
T as a tomato.
2 T's.
S as in sun.
I'm sorry, there is no S. Simon.
A.
I'm sorry, there is no A. Vinyak.
I.
There is 1 I.
Do I get to pick another one?
5 seconds.
Yep. Yeah.
Oh.
Quickly. You get to pick one quickly.
Yeah, it has to be.
Oh.
It has to be fast. I'm sorry about that. Okay, Martin. I believe it is your. Okay, let me get you over there. All right. H.
H.
Yep, 1 H.
N.
We have 2 N's. The clue is title.
Pi. A P. No, P is the. I hope that's the. I'm expecting something. A Y.
1 Y.
Oh, this is getting dangerous. I'm getting an O. I spent my money on an O.
Okay, actually, there are 2 O's. That helps you out on that first word a bit.
Oh.
2 seconds.
L.
L. Yes, we have 1 L.
I'd like to solve.
Okay, go for it.
Violent Python.
Violent Python? Absolutely. So Martin is now in the lead with 650 points. Simon is only barely in the hole with 50. You'll get out of that easily. And Vinyak is safely at 0, but anything can happen. So let's jump to the next puzzle here. And the clue for this one is, what are you doing? And Simon, you get to start first.
Let's go with P.
I'm sorry, there is no P. Vinyak.
N O.
There is 1 O.
E.
There are 2 E's.
I.
There are 2 I's.
C. O.
Oh, I'm sorry.
No.
There is no C. Martin.
Oh, no.
Dun.
R. As in, yeah.
Yep, there are 3 R's.
S as in software.
I'm sorry, there is no S. Simon.
Mm.
5 seconds.
Yeah. Sorry.
Next.
Yep, absolutely. Okay, Vinyak.
A.
A, you say? Yes, there are 3 A's.
T.
T as in Tom?
Tom. Yeah, T as in Tom.
There are 2 T's.
L.
There is 1 L.
Ooh.
Oh. M.
No,
I'm
no.
sorry,
no.
You're handing it to Martin.
Oh.
Come on, Martin, you can do it.
Oh, yeah. N as in north.
There are 4 M's.
Oh.
No, come on, Martin, solve it.
Sorry, you said G? All right. Yes, there is 1
question.
G.
I'm going to solve this, hopefully. Training a neural network.
Training a neural network. Absolutely. So Martin is really soaring ahead here.
Oh, this
How are
is
we doing on
deja
time,
vu.
Lace?
I don't even know what to say. Like, I think he got access to the puzzle beforehand. Was that it?
No, there's no possible way. That's a private repository on GitHub. There's only 2 people with that, unless you're a spy, Lais.
The hint confused me. I wasn't training a neural network right now.
Oh boy. Lais, do we have time for one more? Or another one, I should say.
Do indeed. There's only 5 minutes past. So let's go another one.
Okay, let's see if someone can pull ahead of Martin here. Okay. And by the way, anyone who's watching, before I get this first letter, anybody who is watching, you will get an opportunity to play this coming up and possibly challenge Martin, but who knows? Simon or Vignac may surprise us. So the clue for this puzzle is talk, and Simon gets to go first this time.
Sorry, did you say talk?
Or no, not talk, title. I can read. Yeah. I can read. Yay! Not talk. No, I don't. And don't go looking for a talk title here, because I swear that was just a brain glitch.
I will go with E.
Yes, there are 2 E's.
A.
3 A's.
I.
I'm sorry, there is no I. Vignac.
T.
T as in Tom?
Yeah.
Yes, there are 2 T's.
H.
There are 3 H's.
Ooh.
O.
Yes, there is 1 O.
N.
Yes, 2 N's.
I would like to guess. Learn Python the hard way.
Ooh, nice.
Let's see. Here we go.
Let's see.
Learn Python the hard way. Absolutely.
Yay!
Yay! Finally.
Yes. You're in trouble now, Martin.
Yep, he's getting there. He's getting there.
But Martin gets to. Does Martin? No, actually, no. Martin does get to do this one. That's right, because Vignac solved the last puzzle.
Yep, and we have time for another one.
So Martin.
Oh, it's an N as a no. I didn't say. Oh, well, I accept that.
Yeah, you gotta be careful of that O.
N. That's the one I wanted.
Okay, 3 N's.
T.
Yes, there is 1 T.
An
5
S.
seconds.
Oh yeah, actually, you were just on the buzzer there. I was counting in my head.
Okay.
Sorry, Martin.
Oh, no
Okay,
problem.
so that means Simon, it is your turn.
I.
Yes, 4 I's.
F.
S as in Sam,
No, F for fist or Freddy.
or one of them actually.
Ooh. 5 seconds.
A.
Yeah, I'm sorry. Actually, yeah, Lais called it. We were at 5 seconds. I can't flip between these controls very quickly. I'm sorry.
No worries at all. I
That's
just
fine.
5 seconds.
Why?
Y. Let's see here. We have a Y. No Y. I'm sorry. It's back to Martin.
Oh no.
I want to buy an E.
Oh.
Yeah, there are 2 E's.
S.
Yes, there is 1 S.
M.
No.
No, there is no M. Simon.
I will solve it with recursion.
Ah!
Infinite recursion, you said?
That could work, yeah.
Oops,
No,
hold on.
stop.
I misspelled. Hang tight. I have a special key for this. As soon as I can get it to work. Come on. Back. I had the key. Oh, darn it.
Oh, that means I get to.
Vignac can solve it.
No, I think. Hold on. I see.
No,
Yeah, hold on.
Vignac can solve it.
Yeah, there we go. Sorry about that, Simon. Yeah, you are good.
Yeah, I'm back to 0. But I was hoping that Vignac could get in striking range of Martin.
Sorry about that. Absolutely. Ladies, how are we on time?
We have a minute left. I don't know if we have enough
only
time.
a minute left. Well, then, unfortunately, at that point, I think I'm going to have to call this round and say Martin has won with 1,500 points to Vignac's 650 and Simon's whopping 0. But hey, 0 is an important number. Lais, tell Martin what he's won.
Oh, Martin, my dear, you just won a no expenses paid trip to the Pacific Garbage Patch. Come for the sights, leave because of the smell.
Nice. Thank you. That was great.
Thank you for the game. It was really nice.
You're welcome. You're all welcome to. No, Martin is welcome to stay for the next round, right? And then we need more people to defy him. Try to get Martin.
Yes, we have one challenger.
If Martin hasn't terrified everyone from trying to compete.
We should totally help the other participants to beat Martin.
Yeah.
Challenge.
We have one. We have one volunteer.
I would like to challenge as well. I can't raise my hand though because I still got a panelist, right?
Oh, no problem. You never got dropped as a panelist. Oh my! How long have you been sitting there, Elias?
Well, my talk was at 9 a.m.
Okay, Simon and
Vignac,
I'm going to drop Simon and Vignac back to attendee, but you guys are welcome to stick around. And hey, if we don't get enough volunteers, you are welcome to try again.
Yeah.
All right. So we got Elias, and have you promoted Adinata?
Yes, Adinata is
Adinata.
Adinata, sorry.
All right. Fantastic.
Welcome.
So I actually should have done introductions earlier. I'm a terrible person. I'm sorry, Simon and Vignac. I was supposed to do introductions. So really quick, I actually want to know. So Adinata, where are you streaming from?
Streaming from San Francisco. It's sunny right now, so totally on different time zone.
Nice. And I wanted to ask, what is the weirdest thing you've ever done with Python?
That's interesting questions. The weirdest thing, I think so this is not what I actually use, but it's someone that you created in my company. It's basically to allow to detect all the files that have more than how do I say it in English? Or let me answer it different way. What I not the weirdest, but it's all actually what I'm going to talk tomorrow. It's the unit test. Basically, I use Python to run unit tests in a serverless in AWS Lambda. So that's kind of weird in a way, but that's interesting thing.
Definitely, I've never heard of that. Never heard of that particular combination before. There you go. Elias Missler, where are you joining us from?
I'm joining from Glasgow.
Glasgow. And what is perhaps the most memorable bug you've ever encountered, briefly speaking?
Ooh, that's a tough one. Because the memorable ones are the ones that take the most time to fix, which are probably the hardest to put into words. It's the silent ones that creep in somewhere, are hard to find, hard to fix.
Absolutely.
I'm just gonna go with that if that's okay.
Oh, that's totally valid. And then of course our returning champion Martin Boris, who I should have asked earlier, where are you joining us from?
Well, it's North Germany, the border to Denmark. So it's in Flensburg.
You then do work in both the German language and in English when you're working with programming stuff, right?
Yes, and company language is also English for all the non-German parts.
So what I was going to ask then is, what is the weirdest? What's kind of one of the weirder language jumps to make in terms of like some word that just doesn't really make sense when you translate?
There's one thing. Germans cannot say the word squirrel. It's very hard to say. So if you're talking about these little animals that jump around, collect nuts, I try to avoid saying that word because I just can't pronounce that.
There you go. Well, you will be glad to know that that word does not appear in any of our puzzles today.
Awesome.
You will not be challenged to try and
Oh,
solve the
and
puzzle.
by the way, since Elias has not shared a memorable bug, I will have one for you because it's a great one to do. When I was beginning Python, like the first 2 years, I did opening files and closing files without the with statement, and I forgot the brackets behind the close.
Oh no.
So that was in production software that would crash every 2.5 days because it has used up all the file time. It would open a new file every 2.5 seconds. then after 2 days, it would run out of its memory, and then hunting that thing was interesting. Let's put it this way.
I can imagine.
Well, if we're going down this route, can I say a weird one as well? I was
really quick. Sure, why not?
Experimenting with some classes, and for some dynamic thing, I didn't like the syntax and kind of wanted to work with square brackets. So I started overwriting several dunder methods on a class to make it act like a dictionary, but actually have methods on there in square brackets that you could then use in a configuration and call them. It was super weird, and I was so glad when I deleted it finally, but it's possible.
Some amazingly horrible things are possible. I'm just glad we finally fixed the true equals false, false equals true. You know? Okay. Well, I'm gonna stop messing around with the soundboard and trying to be a smart aleck, and let's get to this round. So,
yes. So I'll start the timer.
All right, here we go then. So, Adenata and Elias, you guys familiar with the rules from the previous round?
Yep.
Yes.
All right, cool. Then let's jump into it. So the clue for this first one is thing, and actually, Adenata, you get to start this round.
E.
All right, there are 2 E's.
H.
One H.
Pi. I mean P, as in Papa.
We all do that, I noticed. 2 P's.
Let's say Y.
I'm sorry, there is no Y.
Could I get an R?
R, yes, we have 2 R's.
A T?
Yep, there are 2 T's.
An S.
S, there is 1 S.
A U?
Yep, we have a U.
O?
And we have 2 O's. Oh, I'm sorry. You are out of time. Martin, it is your turn.
N.
There's 1 N.
M.
There is 1 M.
That's the wrong place.
G. 5 seconds.
G, yeah. I'm sorry, G you said?
Yes. It's
G,
not in
okay,
there.
I gotta go back there. Sorry. What was the letter?
G.
G is in golly?
Garage. As in garage.
As in it is Adenata's turn.
C, as in Charlie.
Yes, 2 C's.
Phi, as in phi, like volleyball, phi, vector.
I'm sorry, there is no F.
Not F,
LV,
but
volleyball.
yes.
I was thinking. I actually heard you say volleyball,
Folly.
like folly as in foolishness. Yes, there is 1 P.
Okay, guessing vector machine, support vector machine.
Support vector machine. Absolutely. Adenata has 550 points, Elias 250, and Martin, shockingly, has only 50 points. The world has turned upside down.
Simon is saying on the Q&A that volleyball would be a great game, and I think we should come up with volleyball for next EuroPython.
Absolutely.
I like that idea.
I do, volleyball. That is fantastic. Adenata has come up with a brilliant idea, and he didn't even mean to. All right. So, are we good for our next round, ladies?
Sure.
Yes, indeed. Yeah, we still have 7 minutes left.
Cool. All right. So this round is called "What Are You Doing?" is the clue, and we start with Elias.
Can I have an N?
There are 5 N's.
P?
I'm sorry, there is no P. Martin.
A.
There are 2 A's.
I.
There are 2 I's.
T.
3 T's.
O.
There are 3 O's.
Five seconds.
Yeah.
What
Yeah,
is
unfortunately. All right. So, Adanada.
M as in mama.
I'm sorry, there is no M, Elias.
I would like to solve as function annotation.
Yes.
Function annotation. There you go. Elias is still in the lead with 750, Adanada with 500, and Martin is now in the game at 200 points. So it is still absolutely anybody's game at this point. And we will move on to this next puzzle here. This one is phrase, and Martin gets to start.
E.
Yes, there are 2 E's.
S.
There's 1 S.
T.
1 T.
I.
There are 3 I's.
M.
2 M's.
O.
1 O.
N.
Whew, just in time there. N.
Yep.
There's 1 N.
R.
Oh, actually, I'm sorry, you were just shy. Adanada.
C as in Charlie.
Let me make sure I'm on the right pane. There we go. 1 C.
What is the first sentence? A as in alpha.
There is 1 A.
H as in hotel.
There is 1 H.
D. I don't know.
Sorry. Elias, it is your turn.
K?
I'm sorry, there is no K. Martin.
P.
There is no P. Adanada.
F.
Sorry, there is no F. Elias.
G.
Yes, there is 1 G.
Ooh. Simon is saying that this one is easy.
N? No, we had N. Sorry.
Yeah, I'm sorry. Yeah, N is already used. Martin.
I will try to solve that.
Will you?
Time machine.
Guido's time machine. That is absolutely it. As soon as I can get the bell to play here. Come on, bell. There we go. Fantastic. And in case anyone is unfamiliar with this phrase, this was coined because usually by the time someone would suggest a new feature for Python, Guido would have already implemented it, thus leading to questions about whether or not Guido possibly had a time machine. Of course, it's the same community that questioned for the longest time whether or not Tim Peters was actually just a very advanced chatbot. So,
We're awesome. We have time for another one. There's still 2 minutes and a half. Come on.
Absolutely. So Martin is catching up to Elias, who is still in the lead. Now Adanada is here with 550 points. And you never know what's going to happen, but Adanada gets to start.
E.
There are 2 E's.
T as in time.
I'm sorry, there is no T. Elias.
N.
There are 3 N's.
U.
There is no U. I'm sorry. Martin.
S as in software.
I'm sorry, there's no S. Adanada.
M as in mama.
There is 1 M.
A as in alpha.
There are two A's.
C as in Charlie.
One C.
H. I.
Two I's.
Machine learning.
And add that over. Machine. Oh, I got to spell it right. Machine learning. Absolutely.
Yay.
Got one of those as well. And has just pulled in front of Elias.
Wow.
Talk about sudden death.
It's incredible because we still have a minute and a half left.
Oh, we have a minute. Oh, that's right. Minute and a half. And oh, that's right. We do. Is that enough time for one round, Lace?
I think if we squeeze it. Yeah, let's go. Another
Okay,
one.
let's try it. Oh, it's a short one too. So who knows? Okay, so what are you doing? Is
For the game
and,
now.
Elias.
Okay. T.
T. There are 3 T's.
N.
And there are 2 N's.
G.
There is 1 G.
I.
There is 1 I. 2 I's. Sorry, Martin.
S.
There is 1 S.
I would like to solve.
All right.
Unit testing.
Unit testing, absolutely. But despite that, Elias getting as far as he did, Elias is the winner of this round. Congratulations.
That was a close call.
And we finished within 10 minutes. We finished with 20 seconds left. Can you believe that?
That is absolutely incredible. So, Elias, tell him what he's won.
So Elias, you won a no expenses paid 2 days, 1 night camping trip to see the winter solstice in beautiful Antarctica. How do you feel about that?
That sounds wonderful. That sounds absolutely wonderful.
So happy you're gonna enjoy your trip.
It will be the coolest trip.
Oh, very. Yes.
I just love how much you love the soundboard. It's like,
yeah, this is all sorts of fun. This is great. So Martin and Adanata, thank you so much for playing, and we are now looking for 2 more players to now challenge Elias, and we have 1 volunteer, 2 Oh, right.
Ooh.
So if you want to onboard the 2 new ones, I will drop off Martin and Adanata. Thank you so much for playing.
Absolutely. So, and we have Nico as well joining us. Dun, 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 dun. And Simon, you need to join. If you're going to keep doing this, you need to join as well. And the next round is you.
Yeah, absolutely, Simon. I think at this point it's practically mandatory.
So it's dark me now because at night the light is behind. So.
What's going on? Where are you?
Oh, there you are. Okay. Oh, and we get Vignac for another round. He's going to try again to unseat the opponents.
I'll try my luck again.
Absolutely. And I get an opportunity to redeem myself. So, Vignac, where are you streaming from? I never asked.
I'm from New Delhi, India, right now.
All right.
Yep.
And what is the when I say this, what's the first thing that comes to mind? What when I say saying I told you so to a coworker or a boss?
I can't really remember. I told you so right now, but during the game, if I remember. But if I remember it during the game, I'll totally say it. Let me just try to remember it while the other contestant joins in.
All right, I'll come back around to you then. So, Nicholas, where are you joining us from? I think I know.
I'm in the dark side. No, I'm in Amsterdam.
Amsterdam. All right. And what is your favorite bug that you've ever fixed?
A bug I fix or a bug I never fix?
Oh, I guess you could say never fixed. I guess there's favorite bug.
Oh, I don't know. Yeah. I don't know if the bug was nice, but the reporting was amazing. So, like more than 10 years ago, I was working with some MS-DOS software written in Clipper, and we got a report from someone saying that the only way for the computer to work was putting a fan next to the computer. And he sent us a video of that. So this person was like executing a command and then putting a fan next to the computer. And he explained all of that in an email and sent a video of he doing that. So the bug was silly, was something doing I remember now, like a eternal loop. But the bug report was the best bug report I've seen in my life.
Excellent. It was good to see a good bug report. And Elias, I don't think I've asked you this one. Have I asked you this one before? What is the weirdest thing you've ever built in Python?
You didn't ask me, but I did answer to it.
Oh, you did answer to it. That's right. That's right. See, I got to come up with these questions kind of on the fly here, and so that's that's the trick. Well, I'll ask this one: Is this your first time? Is this your first time participating in some sort of quiz game?
No, I've done a fair amount of pub quizzes that I never knew anything for. So winning something has been great.
Absolutely. And I'll just come back around to Vinayak really quick. Have you thought of that thing yet that you're thinking of?
There's just too much adrenaline from being in this game. I'm just so excited that I can't think of anything right now.
No worries. Not a problem. All right. Well, I'll get some of the pressure off here and we'll start the round. And actually, I don't know who's going to get to start. We're going to find out. Actually, apparently, it's Elias gets to start this round. The clue is thing.
I'm going to start with an H.
Oh, and there is no H. Vinayak.
An I.
I. We have one I.
O.
We have two O's.
An A.
No E. I'm sorry. Nicholas.
U.
There is one U.
N.
Two M's.
P.
P as in Python?
Yes.
There is one P.
R as a...
Sorry, which letter?
R as rock.
Oh, rock. R. Three R's.
G.
Right on time. Three G's.
Oh.
I'm sorry.
Time.
Yeah.
Sorry.
Elias.
That's an A.
Yep, we have two A's.
N.
We have one N.
C. I want to solve as cargo cult programming.
Cargo cult.
Yeah.
Programming. Oops. I think,
two M's.
Nope.
No, it was you.
I misspelled.
Yeah.
I misspelled. Hold on. Oh, why can't I go back? Oh, that's right. I know why I can't go back. Cargo, Colt, programming. There we go. Okay. Where did the... Oh, yeah. Okay, yeah. So you did solve that. And here's your bell sound. But Nicholas is, in fact, in the lead anyhow, just from guessing the letters. So we'll see who... still anybody's game here. So this next one is person. And this is generally a... Actually, I can't remember if this is a name or I think this is a title. I think this is a title of a person. As a generic term as opposed to a name. Vinayak.
An E.
E. Yes, one E.
An O.
I'm sorry, there is no O.
U.
There is no U, Elias.
N.
Two N's.
T.
There is one T.
A.
We have three A's.
F.
I'm sorry, there is no F.
An I. An I.
Yes, we have three I's.
M.
One M.
An R.
3 R's.
Oh no, I can't guess the first word.
5. Oh, I'm sorry. So this now goes over to Nicholas.
I'm thinking, I don't know. F?
Sorry, there is. So actually, F is already used. Elias.
S like singing. No.
Sorry, there is no.
So
S.
I'll guess it's a library maintainer.
Library maintainer. And
Yay.
that is it. So Vinayak and Nicholas are tied for second place at 400. Elias is barely in the lead with 450. Lais, how are we doing on time?
We are all good. We still have half of the time.
All right. So next puzzle. This is title. And Nicholas, can I get a letter?
O.
Yes, there are 2 O's.
P?
P as in Python?
Yes.
Yes, there is 1 P.
R as rock.
No R, I'm sorry, Elias.
L.
There is 1 L.
E.
3 E's. Hopefully that'll help some.
N.
I'm sorry, there is no N, Vinayak.
An L. Oh,
L
it's already called
is
out.
already taken. I'm sorry, Nicholas.
M.
M, we have 1 M.
C.
We have 2 C's.
D. Yes, code complete.
Code complete. Make sure I type that right. Absolutely it. Nicholas pulls into the lead at 900 points to Elias's 450 and Vinayak's 400. And I think we still have time, right?
Yes, we do indeed.
All right, so let's see what happens now. This puzzle is thing, Elias.
Is there a T?
I'm sorry, there is no T.
An I.
There is no I.
O.
There's no O either.
Is there an N?
There is 1 N.
Is there a D?
There is 1 D.
Then an A, please?
Yes, otherwise we would have some questions. There are 3 A's.
P as in Python?
Yes, there are 2 P's.
S as in sing?
Yes, we have 2 S's. And I was actually just about to hit that buzzer when you asked. So sorry for the delay on that, by the way, as hard to switch between the 2 panels. Vinyak.
An M.
M? Yes, we have 2 M's.
A C.
A C. I'm sorry, there is no C. Nicholas.
An F.
There is no F. Elias.
K?
Now there is no K either. Vinyak.
A G.
There are 2 G's, actually.
An E.
Yep, there are 3 E's.
I would like to guess.
All right.
Salmon eggs example.
Something you only find in Python. Absolutely right. All right.
That's new even for me. I didn't know about this one.
And I think do we have time for one more to decide this round because we're now tied.
We do indeed. Let's go. The last one.
All right. So let's see if we can decide this round because Vinyak and Nicholas are tied. Elias is in third and Nicholas gets to start.
P of Python.
There is 1 P.
O.
There are 2 O's.
N.
2 N's.
T.
There are 2 T's.
C.
I'm sorry, there is no C. Elias.
Can I have a Y? An H?
There are 2 Y's. And then what?
H?
We have 1 H.
An F? An R?
R. One R.
G.
I'm sorry, there's no G, Vinayak.
An I.
There is one I.
An E.
Sorry, no E, Nicholas.
U.
Nope, there is no U either, Elias.
I would like to guess it's Python for data analysis.
Python for data analysis.
That's a very wide
Absolutely.
Oh.
Why is that
That
playing
was
twice is what I would like to know. That's oh, I know why that's playing twice. Okay, I got that.
We have time for one more, actually, to be honest. If Vinayak
do.
wants, yes, if Vinayak wants to get it, like maybe try and turn on the tables. We still have time for another one.
All right, so one more. This is the deciding one. So, Vinayak, letter please. The clue is title.
An I.
There are three I's.
An E.
There are two E's.
An H.
There is one H.
T.
Yes, we have one T.
N.
We have two N's.
A.
We have one A.
A B.
There is one B.
A D.
Sorry,
no.
there is no D, surprisingly. Nicholas.
M.
We have one M.
G.
One G.
Oh.
I don't know what's it. C.
There is one C.
S.
One S.
I don't know. U.
I got it.
Oh, and I was actually just about to hit the buzzer on you, Nicholas. I'm sorry. We're actually right out of time.
Mine in the...
All right, so up. No, it is Elias' turn. There we go. Elias.
Can I have a U?
Sorry, there is no U. Vinny.
I would like to guess mining the social web.
Mining the social web. Absolutely. Yes.
You see, that's what I said. I guess we have a winner now because there's no one card.
Absolutely. Tight game. That was fantastic. So Vinayak is our winner at 1,250 points. Nicholas and Elias are right behind him at 1,150 and 1,100 respectively. Great game to all of you. Elias, tell Vinayak what he's won.
Absolutely, Jason. So, Vinayak, you win a free admission for 3 to the 1939 New York World's Fair at the scenic Flushing Meadows Corona Park in Queens. Time travel expenses not included.
Thank you. That was really fun.
Yeah.
All right, thank you guys so much. And let's see. So Vinayak gets to stay put and challenge anybody else who wants to take him on, because I think we have time for one last round before we're done for the night. Should we try to get one last one in here, Lice?
Yes. I think Chuck really wants to play. And yes, Mrs. Terminal ZB is already in as a panelist. And then we need one more volunteer.
Oh, and we have a volunteer. Absolutely.
Vaclav wants to play as well. So you're going to become a panelist right now.
So, and Elias, thank you for playing. I'm going to drop you back to attendee. And thank you, Nicholas. I will be dropping you back to an attendee as well.
Yes.
All right. So let me go back here and make sure I put in our names. So we have Chuk and we have Vinayak, our champion. And then we had one more. So what would your first name be?
Chuck?
Yes.
No.
Oh, sorry.
Oh, I'm already there.
Yeah, sorry.
So yeah, so Vaclav, what is that your name then? Don't think I can hear you. You might be muted.
Yeah, we can't hear you, but you're not muted. I think he's haven't joined audio, maybe.
Oh, it could be. Well, he can hear us though.
He's not muted. how's your Jax? Is everything connected? Mm.
Yeah, we'll work with this in just a moment. Let him figure that out. Okay, while he figures that out, just speak up as soon as you got to. Just keep working on it. As soon as you got a voice, go ahead and speak up. In the meantime, I will introduce the other two contestants. So, Chuk, where are you streaming from?
Streaming from London.
And what is the weirdest thing you've ever built in Python?
Wow, I don't know. Maybe the registration board of EuroPython.
That was pretty impressive. Absolutely. And Vinayak, so we were talking to you earlier. I'm trying to think what else to.
1, 2, 3.
Oh, hey, now we got sound. All right.
Can you hear me?
Yes, we can hear you now. So I'll ask you what your first name is.
My name is Vyacheslav. Václav is my nickname, like in Czech, because my grandpa is Czech. I picked up this nickname.
Excellent. So how do you spell that for this? Is just what your nick is?
Václav.
How do you spell that? Sorry.
Václav.
I actually don't know how to spell.
VAC.
All right.
Can you hear me?
Yeah, I can hear you. VAC.
VACLAV.
Oh yeah, that's right. Yeah, Václav, it's your username. I'm not all there today. I've been at this since 5 a.m. all y'all. And where are you streaming from?
From Moscow.
From Moscow. Awesome. What is your favorite bug that you've ever encountered?
Yeah, it's probably more related to database handling. So it was like very hard to spot, but it costed us like 2 hours complete outage. Very high loaded system serving taxi drivers.
Awesome. Well, congratulations on resolving that one then. And Vinayak, so how did you get started in Python?
So I was coming from C++, and I looked at an open source project in machine learning that I could contribute to. And while reading through the code, I could just see how easy it was to read and how beautiful it looked compared to C++. And I've never looked back since. I've been using Python since then.
All right.
Yeah.
Excellent. So Chuk, Vinayak, and Václav, is that am I mingling that? I feel like I'm mingling that.
Nope. Sounds good.
Wait, I have a question about the name of the game. So it's Perl.
Yes.
Is it like related to the programming language or?
No, it's related to the fact that if you guess wrong, you lose points.
Ah.
So you can get negative scores. Unlike the American game Wheel of Fortune, this is based on where you don't really lose points unless you hit a bankrupt. So we will go ahead and get started on the first puzzle here. And Václav, I'm going to try and get your name right, but I feel like I'm completely mingling it with my American accent. Is that
Yeah, no problem.
So
I'm for
you'll have to-
forgiveness now.
Okay. All right. So, and Vinayak gets to start this round. It looks like the title is the clue is thing.
N.
We have no N for Václav.
T.
We have 2 T's.
I.
I'm sorry, no I. Chuk.
E.
2 E's.
M.
That's it. Oh, I'm sorry. I was actually just hitting that button as you were talking. I'm sorry. It's hard to. I got to build that into the source code later. Pull request. Vinayak.
N A.
E.
Oh, no.
I'm sorry. The E is already used for
No,
Cloud.
N A A.
Oh, an
A
A.
for apple.
A. I'm sorry. Thank you for catching me on that. A. There we go.
What's going on right now? Like,
I'm
okay.
having
It's like you're
technical
flying.
difficulties. Yes, I'm having technical difficulties. I am sorry about that. Yeah, so 1A, Vignac.
An L.
L, yes, 1L.
An O.
No O, I'm sorry, Vaclav.
P.
1P.
I.
I'm sorry, the I is already used.
Y.
Yes, there is one Y.
H.
I'm sorry, there is no H, Vignac.
An S.
Sorry, there is no S either, Vaclav.
K.
T's already used. Or were you saying T is in Tom?
No. K.
K, I'm sorry. What is this doing? This is being very naughty to me. Ay.
He was behaving until now, I swear.
I think he's drunk. That's why.
Yeah. Apparently, yeah. No K. I'm sorry. Chook.
G for Giga. No. Okay.
I would like to
No
guess
G.
it's mutable type.
Mutable type. There we go.
I thought there's no M because I said it before. Okay, fine.
Yeah, I'm sorry about that. Yeah, it was right at the. It was unfortunately that one was right at the buzzer where it's going to the next person. I gotta build
There's
that.
no
into the
way
game.
I could win this.
Sorry.
You never know.
Oh dear. All right.
She
well,
has been
look out.
guessing, though. She has been guessing beforehand, and she's been writing the answers on Discord for me.
I can only do the data science ones. Like I can only do the data science ones.
All right, but Clav, if I'm going to do it wrong, I should at least need to do it right.
T.
There are two T's.
B.
1B.
L.
There is no L. I'm sorry, Chook.
Well, it's obviously not Guido von Rossum because it's not. Then I don't know. I would just guess E.
There are two E's actually.
I don't know, like H.
H? No H. I'm sorry, Vignac.
An A.
An A? There is no A. Vaclav.
D.
There is no D.
Okay.
Chook, she's got an advertisement there for Brooklyn Lager.
No, like someone asked me to do it.
Yeah.
No, someone asked me in the chat. No, I'm not paid for the advertisement. No one pays me. They're not sponsoring. They better do, but yeah.
All right, Chook, a letter, please.
G. I don't know, I just love it.
Nope, there is no G.
An I.
There is one I.
An M.
There is no M for club.
N.
N as in Nancy?
Nancy, yeah.
All right. There is two N's.
Okay. Maybe O.
Right on the cusp there out of time. I'm sorry.
And this person got a super long name as well. So I don't know. I don't know what else hasn't been like try as V.
I'm sorry, there is no V. I should point out person is not a formal name, but this is a type of person.
An O.
There are 4 O's.
Ooh.
In a V. Oh, it's already guessed.
No, sorry, he's already guessed. Club.
I guess. I mean, P. Like person.
Actually, there is one P.
Oh.
Oh, can I guess? Can I guess? It's not my turn. Can I guess?
You can't.
Oh, jeez.
Yet. No,
got it.
Can't guess
You have to guess it wrong, please. Guess something wrong. Oh, this is like obvious now, man. Like, Jesus. We should have a buzzer, like almost like you can kind of catch it. Like
Yeah, I would try to guess open source contributor.
Open source contributor. There you go, 550.
Whoa.
There's no way. I think I should win by like the most negative person like today.
You're definitely the most
special
pushy
prize
one.
for that.
Yeah.
I'm just like
And in
going the
case
other
it-
direction, you know, like.
And then in case anyone's watching and just going, hey, why didn't he call time on Vaclav? Well, because we were all talking over him, so I couldn't start counting down.
There is a minute and a half left. Are we
Who
doing
cares?
another
Like,
one?
who cares? Like, I won't be able to catch up anyway. The difference like 700
Well,
or something. Like,
Let's do one more and just see what happens. So, actually, Chuk gets to start anyway. Hey, you could guess several letters right and solve the puzzle and pull ahead. You never know.
the most common alphabet in English is E, so I gotta go with E.
Yes, and thankfully there are 3 of them.
Look at this.
And I have no idea. Like H, those common words. And T.
Yeah, there
H again.
is and then there are 3 T's. You're out of the hole.
Something. Okay. No idea. Still. W.
No.
Sorry, there is no W. Viniac.
An N.
N. There are 2 N's.
An I.
No, I typed wrong. An I. Yeah, there is 1 I.
An O.
Okay, there are 2 O's.
A C.
There is 1 C.
Oh, now I have an idea what the words are.
An M.
An M. There is 1 N. 1 M, as in Mary.
Oh no! Why can't I guess it? An A.
A. There is an A. There are 2 A's actually.
A D.
A D. Okay. There are 2 D's.
So I'll guess it. Read the documentation.
I have to actually go into the correct window. Read the documentation. That is indeed it. So it looks like I gotta play the bell, and actually it looks like Viniac has reigned victorious again.
Another one.
Absolutely. See, that's amazing to me, because here you're taking down my Martin in the first round, and you come back and you're a comeback kid, and you knock out everybody. I mean,
yeah, I wanted to beat Martin though.
That's a challenge. That's a challenge. We'll be here tomorrow.
I challenge you, Martin. I challenge you.
Absolutely, yes. Well, we will indeed be here tomorrow, and yeah, Martin's going. Yeah, I'll take you on.
Yeah, he's definitely like, yeah. Raise my hand. Someone hold me. I want to come back. So he's joining us up on the list now. Let's see what he has to say to defend himself.
So it's getting more like the lightning talk, and people have to wake up at 8 to like go there, like to be there at 8 to sign up. It's kind of like that. Like people have to wake up early to sign up and things like that.
Just come earlier to have more chances.
Absolutely. Now wait, is Simon Cross seriously still? Is Simon still lurking? So yeah, I mean Simon's right there. It's like aren't you gone? Is he dodging this game? Do you think that's possible that he's just dodging this right now?
I thought he was gone, but I don't think so. I don't know anymore. Now, Martin has something to say to defend himself. Let's hear what Martin
Basically, I could just say I accept the challenge, and I'll meet you in this room tomorrow.
Yeah, I look forward to it.
You could like a champions round at the beginning. And we can play for a trip to the North Pole, maybe, because Antarctica is already gone.
Or a trip to Mars.
Well, enjoy the penguins. Like I think that's the only creatures you would see there. So enjoy
that. He did win another trip though, Lais, and you actually have to tell him what it is he won in this round.
Oh yeah, there you go.
Yes, absolutely. So you win a thrilling, no expenses paid family bungee jumping adventure into Mount Kilauea, Hawaii, one of the world's most active volcanoes in the world.
I do want to go to Hawaii though, but I don't like the bungee jump. I would skip the bungee jump. I would give it to like someone that I hate, so they could die, and I would.
You didn't win.
Enjoy the scenery. That's my suggestions anyway. That's my suggestions. That what you should do.
Oh dear. Yeah, so
So
we've
you
got
know
some
what
more-
to do with your trip then, Vinayak. You know what to do.
Totally. Yep.
Yeah, so just remember, it's no expenses paid. So
Got it.
absolutely, yes. That's one trip that'll sear itself in your memory. So for everyone watching, we will be back tomorrow for more of this general madness. So definitely tune in for the Python, the EuroPython after party. We'll have another hour of word peril, and there are challengers waiting, I am sure.
And
So they
still
get to take on.
Yeah, there's still people drinking in another room. So go to the chat, the party hall chat, and you'll see the drunk people there hanging around.
Yeah, I'm
Because
waiting
apparently
for
you have
the
to be sober
Googling.
to score.
Is it a voice channel? Or are we all just meeting on the written one, on the
I think
chat?
they're using the open space or something. I don't know.
Yeah, there's somebody needs to post the link to the Zoom open space in that, so it's easier to click when you're drunk.
Can't read, just show me where to click.
Fun fact, I should mention at this point, you mentioned that there was actually back in the day in Seattle, so there was this little problem with Seattle, and that the elevation was so low that they had water pressure problems. And so what they had to do is they had to build it up. But in order to build it up, what they decided to do is they said, well, we can't get the money to do it right now, so we're going to have to do this over time. And businesses are like, well, excuse me, we'd like to, rebuild after that fire you all just had that you didn't put out. They burned down the entire city of Seattle. Thought that was San Francisco's job, but Seattle decided to get in on the party, and so they built up the roads. So all the businesses were operating as normal, but then they got the city budget to build up the roads. And then as soon as they build the roads up about 6 to 8 feet, then they say, oh, and actually we don't have the money to do the sidewalks yet. So they had to install, the city looked like a giant waffle, basically. They had to install ladders so that you could climb up from the sidewalk up 8 feet to the street above and then down to the other side. And they actually had accidental deaths to the effect of having a horse fall on your head, as a matter of record. So unfortunately, for people staying at the Occidental Hotel, the saloon was on the other side of the street, and they could navigate it just peachy going from the hotel to the saloon, but obviously navigating an 8-foot ladder in the dark when you're returning did not generally fare so well, and so there's a very high accident rate coming off that ladder. So Seattle's got a weird history.
It sounds like it. It sounds like it, absolutely.
They eventually did build up the sidewalks, but fun fact is that the original streets are still there, or the original sidewalks are still there on what's now known as the Seattle Underground. So if you get a chance to be in Seattle, Washington, take that tour. That's a trip.
I hope to win that trip next time.
That's what you want, isn't it? Okay, fine. Sure.
Yeah, duly noted. I will take a note of that. All right. Well, thank you everyone for joining us. Like I said, for the Spot of Madness, and we will see you all tomorrow for EuroPython 2020 Day 2. Lots of fun talks coming up. More keynotes. We got Guido's keynote tomorrow. We have another keynote as well, and I should know the name off the top of my head, but I don't. More awesome talks, more lightning talks, and of course, more Word Peril in the evening. And informally speaking, if you stick around after Word Peril tomorrow, there's going to be something to the ilk of what was that, Chook? That was
Slice karaoke. So
Slice
it's
karaoke.
Oh, PowerPoint karaoke.
a PowerPoint. Yeah, whatever you call it. It's just like people will be put on spot to give a presentation of a slide deck that they've never seen before. Yeah.
Awesome.
Will that
All
be
right.
after the party?
Yeah, that'll be
fun to
that'll be
see
the
people-
after party.
It would be fun to see drunk people giving a lightning talk on something they don't know about.
Oh, you'll see at least one sober person trying it too, and I can't guarantee I'm going to do any better. Fun
Thanks
times
for the
ahead.
game.
See you all tomorrow.
See you all tomorrow.
Absolutely. I hope everyone
Yeah, I
had
think-
fun.
This was
Thank you.
a lot of fun. Thanks for taking the time to prepare all this. So that is a really nice game.
That was all
absolutely.
Jason. That was all Jason. It was amazing.
Absolutely. And then I'm going to post the link on the party hall to the repository if anybody wants to check out the game. But remember, the puzzles are not there. So you can play the source code, but puzzles cannot be found. Sorry. So, all right. Talk to you all later.
Wonderful. Bye-bye. It was a pleasure. Have fun. And I'll see you all tomorrow. Bye-bye.
Bye-bye. See you
Bye.
tomorrow.